So Alex Stein comes on this show and starts talking about wanting to go to Antarctica. And I asked the audience, I said, you know, look, it's your guys' memberships that help fund Timcast, the Culture War, the Morning Show, and all that stuff. Should we send Alex Stein to Antarctica to prove that the Earth is indeed not flat and it's not an ice wall? 99% said yes. It's $30,000. And I said, okay, Alex, when are you going to Antarctica? So answer the question.
Well, you know, I guess today we'll make that decision live on the show. But one thing I will say is that we have a great guy here by the name of Austin Whitsitt that is going to Antarctica on this expedition with ALE. So, in a way, I kind of feel like I'm going because I trust Austin. So, I saved you $30,000, so you're welcome, Tim. So
okay, all right.
And you should really. You could give me a check for $15,000 because we're not going to use it, and then we can just call it even.
We'll get you halfway to Antarctica.
I'll just go to Chile. Okay, but this is also, everybody's like, oh, it's so easy to go to Antarctica. First of all, and Austin can elaborate further on this, you have to fly from Dallas to Santiago, Chile, then Santiago, Chile to Punta Arenas, the tip of Chile, and then you got to take a flight from Chile, from Punta Arenas, the southernmost part of Chile, and take a 4-hour flight and land on the ice in Antarctica.
So you think that the Earth is flat and there's a giant ice wall?
I do not believe in the heliocentric model that they described.
Heliocentric.
Well, obviously the Earth is, there's mountains, there's valleys.
No, but heliocentric means that the sun is...
Excuse me, I'm a geocentrist. I don't believe in
that. The Earth could still be round.
Yeah, theoretically, that's what...
Okay, all right. So this is... We're going to... half the chat is like, you're all stupid, and the other half is like, LOL. So let's do a round of introductions for everybody before we just jump right into the debate. Sir, would you like to start with your credentials, who you are, what do you do?
My name is Robert Sungenis, and I've written many books, half of them on science, and one of them is called Galileo Was Wrong, the Church Was Right.
Really?
That's a 3-volume... 2,200-page thing. So we cover the history, the ecclesiastics, the science, and anything else that's available to talk about. So that's one of my claims to fame. And the other is we put out a movie in 2014 called The Principle. I don't know if you've heard of it or not. You haven't heard of it?
No, I've not heard of it.
This is yours.
Oh, all right.
Tim, you need to watch that documentary.
Oh, yeah?
It's a very good documentary.
Is it on like Amazon or any streaming service?
It's on streaming. You can buy it on Amazon. You can buy it from
okay, cool. We can put it on afterwards. We'll put it on.
Sure.
Yeah. Because we don't have a DVD player.
Oh, okay. Nobody does anymore.
Right. All right. So it should be interesting.
That was a theatrical release.
Oh, okay,
in 2014, we started in Chicago, went to L.A., and then 15 more cities in the U.S. It was on AMC, Regal Cinemas.
Oh, wow.
So it was a big deal, but it got shot down, and it became a flop because we had a lot of enemies.
Do you want to pull your mic up a little bit closer?
Sure.
Just, point it upwards. Right. We'll get into all of that. So you're a doctor, though. I think that's important, right? You have credentials.
Yeah, I have credentials.
There you go.
All of them are in theology.
Oh, excellent.
But I was a physics major in college, too, so I know some of the science.
Oh, very, very nice. All right, sir. How about you, good sir? I hear you're going to Antarctica?
Yeah. My name's Austin Whitsitt. I run the channel Whitsitt Gets It. I describe myself as autodidactic, maybe. So I just dove into cosmology a lot over the last few years. So that's my primary focus. It is not what we have been told. It is cosmology. And yeah, I did a lot of activism during the 2020 range. So that's kind of what started me down making content. So yeah, I primarily focus on cosmology, and I'm going to Antarctica.
All right.
And should be exciting.
And you think the Earth is flat?
Yes.
Austin's the number one when it comes to flat Earth, backwards and forwards. This guy knows it better than anyone else in the world. So.
And we got one more gentleman with us, sir. Who are you?
So my name is Scott Ferguson. I run the channel Astronomy Live. I have a PhD, but it's in neuroscience. But Austin invited me to come here today, I guess, as a representative for the mainstream science. So I do amateur astronomy. I develop a lot of software for tracking rockets and satellites.
Sorry, can you pull your mic closer?
Yep. Yeah, so I develop software for tracking rockets and satellites with off-the-shelf telescopes. Film a lot of rocket launches, film a lot of satellites, ISS, all kinds of stuff. I've measured the radius of the Earth, the distance of the Sun, the distance of Mars, the distance of various satellites. So yeah, I mean, my amateur astronomy hobby probably has some applicability, but for full declaration, like my PhD in neuroscience is irrelevant to the discussion today.
I watched a video on X, and it was a rocket launch, and the rocket gets way up, and then all of a sudden it explodes. And I was told that it was the rocket hitting the firmament and blowing up, and that proves it, doesn't it?
In a way, it does. But, it's funny though you say that because there's videos online, Tim, of like a little kid being like, "Daddy, why is that rocket curving?" If you ever see a rocket launch, they always do curve.
It's the Coriolis effect.
Yeah, right. I'm sick of this. And then this another thing is, well, because my biological stepfather, Tucker Carlson, I love you very much, Tucker. Thank you for everything you do. He came on my show and we debated flat Earth a little bit, and he's like, "Well, I don't think it can be flat because snipers have to factor in the Coriolis effect." Yet, if you talk to any sniper, they never have to do that calculation. There's not a sniper that's ever done that in battle, done a Coriolis mathematical equation to figure it out.
Well, Google says you're wrong. And if Google says that
Google
proves
also says, what does it say? It says a man can have a baby. So, I mean, Google says men can get pregnant.
I gotta be honest though, that actually does make it challenging to a certain degree. Obviously, you can measure these things, but when Google tells you men can get pregnant, it does call into question a lot of the claims they make, because we're like, hold on there a minute. But without diving into that subject, there's an interesting point about whether we trust mainstream acceptable knowledge, right? And so if we go back to hundreds of years, and you'll know this better than me, but when the view was that we were a geocentric solar system or universe, that was the mainstream view, was it not?
Sure.
So people generally accepted the Earth was the center of the universe.
Well, the Greeks were divided.
Oh,
Pythagoras was a geocentrist. By the time of Aristotle, the same thing, but Aristarchus of Samos was a heliocentrist, and that's where Copernicus got his model from, Aristarchus. Copernicus didn't really do much work, measuring planets and all that. So he got it from the Greeks, but he got the same model that was built on circles. So his model really didn't work well until Kepler came along and put them in elliptical orbits, and it worked a little better, but it still wasn't perfect. But Copernicus basically was copying from the Greeks.
So what's your view? You think it's a geocentric solar system or universe? How would you describe it?
I do, yeah. And with Newton, that was not allowed. Newton had equations, F equals ma, and some other ones that only allowed a heliocentric universe. The rest of the universe was absolute and inert. It had no effect on our solar system. So the way Newton figured things out was the sun's the biggest thing, has the most gravity. That means all the planets have to go around it, including the Earth. And that's all his system would allow, because he dealt only with the solar system and forgot the rest of the universe.
Oh, interesting.
Okay?
Well, so is the Earth stationary?
Yeah.
So you do believe in a stationary Earth?
Oh, yeah.
What do you think about that, Scott? You don't believe in that, obviously.
No, I mean, so in general relativity, we can describe a reference frame in which Earth is centered and stationary. But general relativity says there is no preferred reference frame. You can't have an absolute reference frame in general relativity. It just doesn't work. So, you can describe things that way. But yeah, in my view, it makes sense that, the sun has the most mass in the solar system. Sure, you can describe a reference frame where Earth is stationary, but you could equally describe one where we go around the solar system barycenter. I'm not a heliocentrist in the sense that I think that our solar system's the center of the universe. Obviously, and I'm sure we'll get into it, but there's a lot of talk about the cosmic microwave background radiation, and that's basically a fragment from, the Big Bang, where you have this leftover radiation, and certain aspects of it seem to suggest that it aligns well with the ecliptic plane, which is the orbits that the planets go around the sun. But those alignments are not as exact as some make them out to be. And there's also the fact that we have an annual shift in the cosmic microwave background radiation. You can actually see a modulation of it as we go around the sun every year.
Yeah, but in the cosmic microwave background, it does, in that picture, it shows the Earth as the center of the universe.
I got to do a pause real quick because we got fact checked by someone in the super chat already.
Yeah, that's not true. Google does say
No, I'm sorry. I Googled it, and Google says no. So
it used to say yes.
Look at this. Google's AI says no. A person born with male reproductive organs and living as a man cannot get pregnant.
Wow.
Wow, that changed.
It says, however, some transgender men and non-binary people can become pregnant.
The Trump effect?
Well, it used to be yes. Oh, but back to the cosmic microwave background.
Yeah, back to the.
It says if you do believe that is a real thing, right?
Of course.
Yeah, and it does show that the Earth is the center of that.
Well, what it shows is it shows certain alignments, but they're off by anywhere from 8 to 17 degrees if you convert it to ecliptic coordinates. So if you the cosmic
That's not
microwave
much.
background-
I mean, you're making it sound like that's a whole big deal. It's not much.
But I
because
think-
you have the quadrupole, the octopole, the axis of evil, three that are different, and so they're going to be shooting up in different
But
directions.
those are all different from each other as well. They're all
yeah,
about
but
8 to
but they're
17
not different in
degrees.
the sense that they're looking at a different microwave radiation. They're just modulating it differently because now you have 8 harmonic.
But I'm saying they're not all co-aligned. They're off by 8 to 17 degrees. I mean, it's
Yeah, but
it's
the
an
middle of
interesting
that
coincidence,
8 to
but it's
17
not-
degrees is the axis of evil.
Right.
That's the issue.
What is that?
The axis of evil is a term given to one of those directions that is aligned almost exactly with our ecliptic plane, 23.5 degrees. Okay, so if you're supposed to be out there in the remote recesses of space, like the Big Bangers think, the Earth is just out there with everybody else. It has no significance, no speciality. How is this radiation aligned with the Earth-Sun ecliptic plane? When it's
Accident?
just
Coincidence?
But again, my point is the alignment is not that exact. The quadrupole is
it's
is
enough for
23
the
degrees from
scientists to
equator.
say this is something.
They called it evil. All right, let's make sure everyone understands it. So in the globe model, they say the Earth is tilted at 23.4 degrees. So
And then
it's-
but real quick, sorry, Austin's about to go on a very good rant, and we need to let him talk. But when you say that tilt, Tim, 23.4 degrees, subtract that from 100. What is that?
90. Subtract
Excuse me,
from
from
a
90
degree
degrees. What
angle.
is that?
23.4, 66.6.
6.
666. And then how fast is the Earth orbiting the sun, Austin?
66,600 miles per hour.
Is that true?
That is true.
That's sign. He says yes.
That's true. And tell him, is that not
in
true?
the
Is it not going
heliocentric
60?
model.
So,
Right.
so Earth's orbital velocity is constantly changing. There's no one exact value. And if you look at it to
What's
you
the
know,
What's the average of it?
average.
well, I mean that's about the average, but
That's exactly the average.
That proves that the Earth is flat.
Yeah, there you
Exactly the average. Wait, this is the thing. This is
even
the
the 23.4, that's not exact either, and it's constantly changing. We actually have to calculate this. Anytime we do coordinate conversions to ecliptic coordinates, we have to take the current obliquity of the ecliptic. The tilt of the Earth is constantly changing slightly.
Yeah, he's
So-
right.
But you're just saying that, right? Like this is the thing. This is what always happens. People just beg the question and assert the model and then equate that to being true.
But I
So
measure
what
it. That's the
You
beauty
didn't
of it.
measure the Earth being tilted. What
Yeah,
you
I did.
What you
I
did
did,
was
actually.
you looked at the sun, you reified and assumed your model, you assumed the causation of the ecliptic plane was actually the Earth tilted. That's what you did. So what we see, so I want the audience to understand, we see the sun move in a certain path. They're claiming it looks tilted because the Earth is tilted and it's an illusion. They also claim that what's called the analemma, so the sun does this like extended figure 8 that isn't perfectly symmetrical if you time lapse it throughout the year. They say that's because we're moving. And it makes it look like the sun is moving. So obviously, just in very simple terms, we're saying, oh, the sun is moving. That's why we see the sun moving. You're claiming it's an illusion. So you actually have the burden of proof just on its face, right?
Well,
what always happens is
But Austin,
Real quick. Sorry, just put a pin in it. I'm curious. If you have a geocentric view, why is the sun doing a figure 8?
Well, the analemma is complicated. I mean, I do cover it in the book here, but there is a certain, and the analemma actually moves itself by a few degrees.
What is that?
It's
That's the figure 8.
how the sun is going to, it moves daily, okay, and yearly. There's 2 different movements of the sun. The analemma is going to go by the yearly movement, okay? So that's why it makes a complete figure 8. You get the same thing when they put satellites up in over the Earth. They make a figure 8. You can make them make a figure 8. You can make them make a circle. You can make them do anything depending on how fast you make the satellite move and the tilt that you want it to have along the equator, okay? So the sun has a certain tilt, 23.4 degrees, and it's going to go longer in the north than it does in the south. So you're going to get a figure 8 that's going to represent the different speeds of the sun compared to where the Earth is. And it's complicated, but
But
that's
my point is
basically
simply whether you believe that the Earth is going around the sun or the sun is going around the Earth, you can still measure that. You can still measure
Sure.
that.
Yeah.
Of course, it's an observation. You're assuming the cause of the observation is the Earth is moving.
But you
This
said
is
I didn't
actually what's
measure.
it's even worse though. Like,
No.
let's just use it like really simple terms. Occam's razor. So if you have an explanation you have two different explanations for the same cause or phenomena, right? You're going to go with the simplest one that requires least amount of assumptions if they're both viable. And then if you're going to claim that there's something else that requires more assumptions, you got to verify it. It's actually way worse than this though. It's been scientifically proven with empirical measurement that the Earth is not moving. And we've actually shown that the interferometry correlates to periodicity of the sun, meaning that the solar motion, how light travels and interferes with itself, changes based on the time of year. So it is empirically proven that the Earth is not moving. So not only do we not just grant it to you, right? Because you're just saying the model as if it's true.
Yeah, I think he understands that. And I want to take off from where you left off with general relativity and then go back to his point, if you don't mind. It might take me a couple minutes, but so you admit with general relativity that the sun can go around the Earth can go around the sun, right?
You can describe it that way.
Well, I mean,
Einstein
it has
did
to
say
be
that.
real for you to describe it that way. I mean, in other words, you just can't say it's possible. I mean, we could have one of those scenarios as the true system, correct?
No.
Why?
You can't have either scenario because it doesn't have a preferred frame of reference.
What's it?
Meaning general relativity. General relativity doesn't allow you to have.
Okay,
an
but here's the
absolute frame of
point I was
reference.
trying to make before. Whereas Newton would only allow a heliocentric system, general relativity allows both a geocentric and a heliocentric system. So with the medieval science of Newton, we're never going to get a geocentric system. But with Einstein and Mach, we're going to get it as a possibility. So then it's just a matter of determining which one's the correct one.
No, it doesn't work that way because to suggest that there is a correct one would be to suggest that there is an absolute reference frame. You just got
Well, look, we see this. We see the stars and the sun go around us every day, right? One of them has to be correct. Either the Earth is moving or the sun is moving around the Earth.
From a general relativistic point of view, you don't have any particular reference frame. You can't make an absolute
You're
statement.
basically arguing solipsism. You're saying there's no objective truth at this point.
According to general relativity, there is no absolute reference
General
frame.
relativity doesn't make philosophical
no.
claims about objective truth.
But from our perspective, you're saying that the reference point of how we see the stars and everything moving is the sun is the reference point. We are going around it. That's how we perceive the universe.
That is a useful, that is a useful reference frame in a lot of circumstances. There are some reference frames, like if I'm measuring the motion of a satellite, the first reference frame I'm using is actually one that has my telescope at the center of the universe. And if I'm predicting a solar eclipse and predicting the path of a solar eclipse, I actually use the moon as the center of the universe. So I'm using a selenocentric reference frame. But that doesn't mean I believe that the moon literally is the center of the universe.
Of course.
That's also incorrect, actually. When we map out eclipses, we use ECEFs. We do not use we map out the eclipses with an Earth-centered, Earth-fixed system. Satellites use Earth-centered, Earth-fixed system. You have to actually transform it to an ECI.
But
Earth-centered.
his point.
Austin, that's not what I've done, though. You're talking about maybe something someone else has done. I've personally predicted the path of total solar eclipses, and I've done it using a selenocentric reference frame. I've published this on my channel.
Well, you could use an Earth-centered reference frame too.
And that's what NASA
that's your
actually
point.
does. That's what NASA actually does.
Okay, so let's going to go back to the same point. It doesn't matter what reference frame you use. You see a reality when you look into the sky that something's going around something.
Do you agree?
You can't have them both going around each other.
Why not? You can. I mean, general relativity says you can define whatever reference frame you want, and like I said,
Yeah, but we
depending on the
deal
circumstance,
with the
sometimes it's
reality.
useful to define it as the center of the telescope. Sometimes it's useful to define it as the solar system Barry.
Well, we understand what
real
you're saying.
quick.
It can be either way.
Isn't it in the conventional model that everything is sort of going around each other? That two bodies impose gravitational pull on each
that's how
other?
Newton got to the heliocentric version. He said that there's a center of mass between the sun and the Earth.
Yeah.
But since the sun is bigger, the center of mass is going to be more inside the sun than it would ever be to the Earth.
And so, but the Earth does pull on the sun. It's just negligible.
Negligible, yeah. So, but the fact is, you can have that system where the Earth is going around the sun, okay? Or, to explain what we see in the sky, the sun and the stars can be moving around a central Earth. And general relativity allows that. His thing is like, well, it doesn't make any difference what general relativity allows. It can't pinpoint what the actual thing is.
Well,
I agree.
But
I agree. The fact is that it allows it. So we can't base our decision on what Newton said, because that's what everybody does today.
But isn't the simplest argument, I suppose, is that when you map out the pattern of planets in a geocentric model, they're kind of erratic? And
No, they're not. That's what they make it look like. In the Tychonic model, they're all going around the sun, same as they're doing in the heliocentric system. The only difference is the sun's going around the Earth at the same time it carries the planets in the Tychonic geocentric system.
Yeah.
So it's a very simple system. As a matter of fact,
so
the one that's complicated is the heliocentric system.
let me try. Are you saying that the sun does move around the Earth and the planets are being pulled on by the sun as well?
That's
creating
right. That's right. So it's almost like a mirror image of the Copernican system, except that the sun's going around the Earth.
But so real quick, sorry, I'm trying to understand this. So the sun has pull on the planets.
Yeah.
And do you believe the sun then is not as massive? It's smaller.
No, same sun in both systems.
But is it
what
just
we have now is another force involved because the universe is rotating.
Yeah.
And that's going to cause centrifugal, Coriolis, and Euler forces on the solar system, and it's going to make that sun go in complete tow by the forces of the rotating universe around a fixed Earth.
And so just to clarify, you're saying the Earth is then fixed. It cannot be moved.
Right.
Right.
Doesn't-
Like, let's to
doesn't
make
rotate.
sure-
Well,
doesn't
hold on.
revolve.
I want to ask Robert a question here because I'm curious about this. Let's say that you took a SpaceX Starship and you went to Mars and you had a family and your family grew up on Mars. How would they perceive the universe? Would they perceive the sun going around Mars instead?
They're going to see it from the Mars point of view. And I have no problem with that. The question is that the real system? You can go on Pluto and live if you want, and you're going to see everything revolve around Pluto.
Right.
That's
And
not
so-
the issue here.
So that drives my question then. What is your evidence that it is Earth as opposed to if you grew up on Mars, you would feel like it was Mars?
We've done physical tests on the Earth.
That's where
definitively
Austin
prove it.
comes in.
Yeah,
That's where
so
I was
we've
going to go
definitively
next.
proven it. We have Airy's failure, stellar aberration. It doesn't change when you introduce an additional medium. We have Michelson Morley, and we can get into all these. But interferometry, that was right. Then Michelson go person match the sidereal rotation. I'm not actually trying to scattergun. I want to make sure that the audience is following here. So we have Newton. You have the idea that the sun's really huge. It has the most gravity. The planets move around it, so it's logical that the Earth would also move around.
So Austin, let me ask you a question.
Just a sec. So then Mach came along and said, wait up, Newton didn't even think about the rest of the universe. He thought the sun was the center of the entire universe. So when we actually take his theory even and we apply it to a rotating universe, the angular momentum of that whole universe would outweigh any effect of the sun, and the Earth could be in the center. This spills over into relativity as well. Now, I actually reject all of this. I reject the claim sizes. I don't even believe in all that. But it's misinformation. It needs to be pointed out that even in the Newtonian and Einsteinian models, the Earth could be in the center. So what we need to do is go back to Earth, look at the actual test, the empirical evidence. What does the empirical evidence show? Instead of this woo-woo, we can't know the truth, it could be anything. What does that serve us? We did tests on the Earth that proved that the Earth is not moving.
Well, let me go back to the very first test.
Can I
that you
look
mentioned.
that up? Like what were the studies? What were the tests?
So let me go back to the first
Airy's
one.
failure.
Airy's failure.
Airy, how do you
AIRY. Now, Wikipedia is going to do what
AIRY.
Wikipedia does. Just so you know.
I want to ask Austin this because, okay, so Airy's failure. So for people who don't know, and I'm sure Tim's going to pull it up here in a second. But
Flat
it
Earth
involves-
Wiki? Should I do that?
Well, that's the debunk site, but it's good.
that's
It's
the
still
first thing
good.
that
It
comes
still
out.
can be good because all of them are going to say what's not true, which is very telling that it has to lie.
So Airy's failure, for those who don't know, I'm sure the audience may not be familiar with this, but it involves a telescope filled with water because light travels slower in water. Would you agree that light travels slower in water? Mm-hmm. Okay. So you have a water-filled telescope. The principle behind Airy's failure, which, I mean, this experiment goes back, before Einstein. At that time, physicists believed in the ether, that light was entrained in this ether and that it was called the undulating theory of light, that light was traveling through the ether, a medium. They thought it was necessary. So basically, you have a water-filled telescope pointing at a star. Now, you have stellar aberration because light acts a bit like when you're running in the rain. If you accelerate, you have to tilt your umbrella down to catch the rain. And so starlight acts that way. As we go around the sun, the starlight is deflected slightly by Earth's orbital motion, at least in our model, right? And so if you point a telescope at a star, you have to correct for what we call stellar aberration, the deflection of that starlight. Now, if you fill that telescope with water, the thought was if the starlight is entrained in ether, and think of this as a medium that Earth is moving through around the solar system, then if you slow the light down, but if it's trapped in the ether, it's still going to have lateral motion in the telescope consistent with Earth's orbital motion, and that won't be affected by the water.
Okay.
Let me finish. So what happens in reality is you have a photon of light entering the telescope, slowed down by the water, but the water doesn't have any preferential way of knowing, oh, this vector towards the bottom of the telescope, I'm going to slow it down in this direction, but I'm not going to slow it down laterally. It doesn't work like that. But it would have, at least in theory, if ether were real and it were entrained in the ether. The idea was it's still stuck in the ether. It's still going to have this lateral motion caused by Earth's orbital motion. But because ether doesn't actually exist, and that's what the result actually showed, that photon was coming straight down the tube, the same as it did without the water present. So Airy showed no effect on stellar aberration. The amount of stellar aberration in the water-filled telescope was the same. But the whole reason they expected it to be different was because of ether, the idea that it was going to be entrained in ether and move laterally. So, Austin, my question to you is, if you had your water-filled telescope on Mars and you point at a star, will you see stellar aberration consistent with Mars's orbital motion, or will it be affected by water?
If you went to Narnia, what would be your favorite color? I don't go to Mars, and that's irrelevant. It's a deflection. I'm going to correct. What he just said was the mainstream version. They do this with all truths, by the way. That's why we're going to have a Wikipedia truth box at the bottom of this channel. And they have to misrepresent this test, and it has nothing to do with ether.
Let me pause real quick. So just don't forget what you're going to say. I want to stress one of the challenges is earlier we were mentioning, Google. The argument was Google says men can get pregnant. Well, Google says it's not, but I will stress Wikipedia is full of lies.
Yes.
And so if you look up my wiki, it claims, and this is totally irrelevant to the conversation, but it's relevant to Wikipedia. At some point, they added that I was a proponent of and sought out ivermectin, which is just could not be more false. I argued against it to Joe Rogan on his own show. How they could put in something so false, and all of these editors are like, no, it's true. Tim Pool did this. And I'm like, watch the Rogan episode. I told him no. I said it doesn't work. That whether you agree or disagree on any of the arguments being made on flat Earth presents a troubling scenario where the average person cannot figure out what is to be trusted.
Tim, that's one of my favorite things about astronomy is anyone can look up. It is the most open science there is.
There's no astronomical observation that proves heliocentrism. It all works from a stationary Earth. But I don't want the point to get lost. I don't want the point to get lost. You just went on a long time, and you just said, well, we can read in Wikipedia. The problem with it is, if what Wikipedia is showing is a lie, and you can prove it by going and reading the papers and looking at Airy's actual documents. Have you done that?
I have. And he says that it had a profound impact on the undulating theory of light.
Okay.
Because ether was necessary for that lateral motion of the photon.
You've said that 4 times. Now,
that's what his paper said.
Okay, now I'm going to point out why you're wrong. So you actually claimed, just so for the audience to understand, you have to look at a star with a telescope, and to keep the star in the center of your telescope, you have to tilt it, because it comes in at an angle. So the analogy he used is a good one. It's like rain. If it's raining straight down, but you run through it, even though the rain's falling straight down, it's going to look like it's coming at an angle. And if you run faster, the angle's going to increase, right? So the idea is the Earth is moving around the sun, making the star look like it's coming in at an angle because of the orbital velocity of the Earth. Now, he claimed at the beginning that's why we have stellar aberration, because of orbital velocity. We had nothing to do with ether. You claimed that it comes at an angle because of orbital velocity. What he pointed out was, well, wait, if water's going to slow down the light, that's going to increase the amount of time it takes for the light to get through the telescope. It would be like speeding up in the rain. So it should actually increase the angle. It did not. Has nothing to do with ether. The fact that it may also have an implication, sure, because either light's in a medium or it's not. The test isn't about the ether. The test is about actually isolating the causal mechanism of stellar aberration. So my question is, if you're claiming that it does tilt because of the orbital velocity initially, you claimed that was the cause of stellar aberration, why didn't it change when you increased the amount of time it took the light to get through the telescope?
Because the water slows it down on all axes.
Now, real quick, can you define stellar aberration for those that don't know?
So stellar aberration is what I was talking about with how the rain, if you're running in the rain, you got to tilt your umbrella down. But it could also be the wind is blowing the rain at you, and that's why you have to tilt your umbrella down. But regardless of that, the idea is the stellar light, the light of the star, is deflected either due to our motion around the sun, or if you want to believe the sun's motion and the universe's motion around us. But it's that relative motion that's causing it to deflect. And so depending on what time of year you look at a star, it's going to be in a very slightly different place. It's about 20 arc seconds different depending on which time of year you're looking at the star.
That's the
So-
aberration, just to make it
That's
clear to
the
you.
that's the basic aberration. So that's stellar aberration in a nutshell. Now, what Austin is suggesting is that we should see a different deflection, even without ether, that we would see a different amount of deflection if we slow the light down in water before it reaches the end of the telescope. But the problem with that is that it suggests that water would have some way of knowing that, this vector towards the bottom of the telescope, I'm going to slow it down that direction, but I'm not going to have an impact on the lateral motion due to Earth moving. No, that doesn't work that way. It's going to slow it down, and it will still reach the bottom of the telescope in the same angle that it came into the telescope on, and that's exactly what happened.
Okay, so
That doesn't
let's
make
make sure
sense.
it makes literally no sense. It is if the Earth is moving underneath the starlight. As it goes through the water, it's going to slow down. Now the Earth has moved further underneath the star than if it had gone through without the water, because now it's taking the starlight longer to get to you. The Earth is going to keep supposedly moving 67,000 miles per hour. That means it's going to have a greater angle. There
No,
is
but that
no even
assumes-
mainstream academic rebuttal to this. So your hand wave dismissal, claiming that I'm invoking the sentience of water, doesn't even make any sense. So you've been patently
not
wrong.
a hand wave dismissal, and you're assuming. See, your description of it there has an implicit assumption that because Earth keeps moving, that the light will have a greater deflection in the water. That would imply that this inherent motion caused by Earth's motion, this stellar aberration, has some way of still manifesting differentially from the downward motion of the photon down the telescope tube. It doesn't have any way of doing that.
That's what you claimed. You claimed the reason it came in at an angle was the Earth was moving.
The reason it came in at an angle is because the Earth is moving, but when it hits the water, it slows down, but it slows down equally in all directions. That means the angle through the telescope is still the same, and it still reaches the bottom of the telescope.
What makes a difference whether it's going lateral?
But that's my point. It doesn't. It's a
Okay,
reduction
so then
in
why are
velocity
you adding that
along
in
all
there then?
axes.
You keep saying that.
Because Austin's description implies that it's only going to slow down as far as how far vertically it's coming down. Imagine the stars right above you. How slow it's coming down the telescope, right? Vertically. But in order for it to have a different angle of deflection due to the water, it has to continue to move at the same rate laterally that it did when it entered the telescope. But that requires ether. Because if it doesn't, if the
Why?
ether isn't
Why?
there, because if the ether is not there to entrain it, then there's nothing to cause it to deflect at a different angle as it comes down the water.
How?
It'll simply slow down along its velocity vector, which in this case, in my example, is vertical. It'll just slow down, right? It's not going to go.
The Earth is still
laterally.
moving.
The Earth is still moving underneath it.
Right. The
You're
Earth is still moving.
contradicting yourself. You're claiming it causes an angle change because of the Earth moving underneath it, and then you're turning around and claiming that the Earth moving underneath it wouldn't cause an angle change.
Yeah.
I'm not claiming an angle change during the water transit, though. You're
You
claiming
can't pick and choose. Either it's causing it or it's not causing it. And there's no mainstream academic
This is
rebuttal to
the
this.
explanation, though. It's already angled when it enters the telescope tube, right? It's not going to suddenly change angle because water's slowing it down, because water's slowing it down in all directions. So you can't have an angle change unless something is entraining it, which would be ether.
We can move on. I think.
Okay, yeah, we can move on from this, but Tim, I want you to pull up Werner von Braun's tombstone, and obviously these guys are doctors, scientists, astronomers. I'm not a scientist whatsoever. Obviously, I'm an idiot, but this is why I believe in this stuff. Now, if you type in Werner von Braun, you type in his headstone, it has Psalm 19:1.
Yeah.
If you look up Psalm 19:1, and for the people that are playing at home that don't know who Werner von Braun is, Werner von Braun was a Nazi that we brought over during Operation Paperclip, and a lot of people call Tim a Nazi. They call me a Nazi. But believe it or not, our space program was created by an actual Nazi.
Yeah, we took him, right? Like
yes,
with
Operation Paperclip. We not just took him, we took a lot of their
what was
scientists.
the Japanese what was it called? There was two operations, weren't there? We took the Japanese scientists and the Nazi scientists.
Oh, Paperclip's the one where we took after World War II. We took, and then Russia got
Was
a
it
lot
Unit
of the
571 or whatever.
Russia got a lot of like the technology. But my point is, I think it's very
731. Wait.
So that Werner von Braun Psalm 19:1, and if you look that up, this is the architect of our space program, right, Scott?
So fun story about that. Before I even knew about this tombstone, I like to play video games occasionally. I have an Xbox 360 profile. That's how old I am, right? And my old Xbox 360 profile, I'm a Christian. I had that same verse on my Xbox 360 profile, but it doesn't mean that I think that there's a physical dome. It refers that
Let me read it. So Werner von Braun, 1912, 1977, Psalms 19:1, which reads, "The heavens declare the glory of God, the skies proclaim the work of his hands."
And in some translations, they refer to the heavens as the
Well,
firmament.
See, that's
the
not a
actual
good-
Hebrew,
in the Hebrew it says firmament. Type in-
firm, stereom is the
Is that
Greek.
King
Let's
James
try.
version? Yeah,
You want me to do King James? Which version of the Bible?
Yeah, King James.
Yeah, King James.
21st century King James.
I think that's fine. Yeah, there you
The
go.
heavens declare the glory of God, and the firmament showeth his handiwork.
Yeah, and this will spill over into a theological debate. Obviously, the biblical cosmology.
So Elon's faking it.
So,
Maybe.
So there's all.
Maybe.
I mean, there's
maybe.
all kinds of. Who knows what happens when you get up there? How far you're going?
Elon's whole mission is to shatter the firmament to escape the realm, or what?
It's
I
funny
don't
because
know.
I hope this gets clipped, and I hope Elon sees this, because Elon all day long brags about how these rockets are, taking off and going to the ISS or whatever. Yet, Tim, this is a provable fact. The farthest that NASA has ever sent a rocket is
the moon.
1969 through 1972, the Apollo moon missions that went through the Van Allen radiation belt, which that's a whole kit and caboodle. Like, how were we able to get this film through this deadly radiation back and forth? How did that work? But my point is, we had rockets that could go 257,000 miles in 1969, and today the farthest we can go is low Earth orbit, which is what is it, 120 miles? What is low Earth orbit? How far is it?
500.
Yeah, like 500. I'm saying so. Rockets in 1969 could go 257,000 miles, and now the farthest we can go is 500 miles. It's a pretty big reduction considering it's been 60 years.
Elaborate on that. What do you mean it's the farthest we can go?
The farthest we can go right now, Barack Obama, you can pull it up, it's called low Earth orbit. That's where the ISS is.
The question is, are you talking about the limitations of technology?
But we didn't have that limit of technologies in 1969.
No, I'm asking if that's what you mean, because if I said I can't get to the gas station, am I talking about running there? Am I talking about driving a car there? Is my car broken? Like, when you say the farthest, okay, my point is this. Did we have rockets capable of going that fast we no longer have? Or is the technology and knowledge of how to build those rockets missing?
Well, we had that technology and we destroyed that technology. That's it. According to NASA, is that we had the technology to go to the moon and we accidentally destroyed it. And not only did we destroy the technology and all the blueprints, but we also accidentally destroyed all the telemetry data that gives us coordinates of every point that the Apollo mission was orbiting the moon or, on its,
I hear what you're saying, and the difficult thing is we're talking about the U.S. government, so it's kind of like,
do you trust them?
no, it's like, do you think they're competent? Do you think that they have accurate record keeping? The DoD just failed another audit, like 7th time in a row.
For $800 billion.
There's people have no idea what they're doing in terms of records, and probably a lot of it's on purpose.
Well, this is how you know it's fake, though, Tim, because there's all these. There's all these movies where they'll show like this is how you know it's fake, because there's like a DEI movie of like black women, and no offense, I love black women, I love Medea, but they literally made a movie that like a black woman with a calculator is able to hand compute our calculations to go to the
What
moon.
does that mean? It's fake.
Because a black woman can't sit there with a calculator. Have you seen it?
But why is that?
Explain,
No, hold on.
Why are you emphasizing this?
Yeah, it's black. What does that have to do
Well,
with
it's
it?
nothing about the race. I'm just saying. No offense to. I don't think a woman could do it. It's not. I mean, it's not. It's nothing to do with.
But
race.
a man could.
But I'm saying that's the DEI. It's like they want to make you think like it was all because
No.
of,
The reason they made the movie was DEI. The person existed.
and I don't think they did much. But I'm just saying our space
That's
technology.
white supremacy, Alex.
Well, maybe a little bit, but our space technology is the only thing to retard. We have not gone further in space. We've actually traveled less.
Alex, can you name any of the technologies we lost?
We can't shoot. Okay, first of all, I can't
Like,
just name off the top of my head, but I can tell you this much: when it goes to the moon landing, the manpower that it took us to get to the moon, yet we get to the moon, and the moon is 1/6 our Earth's atmosphere of gravity. Yet the rocket power that it took to blast off from the moon was not even 1/1000th the power that it took us to leave the Earth. And then on top of that, if you see
Well, now we're talking about the moon landing.
because the moon landing is involved in this, and you look at the moon landing clips where the blast crater is. There's no dust. There's nothing. There's not even dust on the.
Well, so we'll go back a little bit because I don't want to jump too far, but keep put a tag on that. I don't want to miss that point. We lose technology all the time. It's actually like a well-known thing. I mean, one of the greatest travesties of human history was the burning of the Library of Alexandria. Who knows what information was lost? Probably a lot of stupid stuff was in there, but there's probably a lot of stuff that we're like, wow. Correct me if I'm wrong. And I mean this literally. Wasn't there something big about Romans had concrete that's set underwater?
Yeah.
We're not quite sure how they did it.
We lost the formula.
Yeah.
Didn't get it back until what, 17 or 1800s?
Yeah. And so when people say things like, "Oh, well, how come we can't do this now?" And I'm like, well, I got to be honest, like the priorities of the Cold War shifted dramatically, and then you're asking if a government bureaucracy with filing cabinets accurately tracked those filing cabinets. I'm gonna be like, yeah, right. they can't figure out how to. They just spent $70,000 on a conference table because they don't know who's spending what where. The government is broken and ridiculously inefficient. Your best argument against the moon landing is that the government's too stupid to pull something like that off.
Well, they also use incompetence as a cover too, right? Like they do that.
They're actually real smart.
Well, no. It's just a great cover where every time they do something wrong, it's like, oh, it was an incompetent mistake. Well, one thing people don't know is because I heard Matt Walsh say, because I'm looking at Matt Walsh here, he says,
Oh yeah, we have the thing on the
yeah. He said, too many people would be in on it. But Krantz talks about how in the control room that the simulations were so good that no one involved would know. It got to the point where you couldn't tell the difference between the simulation and the fake. So, I mean, that's a whole conversation.
Well, let me ask you, Doctor, do you think we went to the moon?
I think it's possible to go to the moon, but I think it's very hard, especially in 1969, to send a man to the moon. That's where I have the difficulty.
And wouldn't they post up there be the best military positioning ever, right? Like you just be on patrol of the world.
Well, and you know how we didn't go to the moon because we'd have a Coca-Cola sign on it. It would be the best marketing tool.
Well, they
in the
say
world.
that we put these laser reflectors on the moon.
Yes,
It's hard to refute if, because I don't know whether they went to the moon or not. But they say they bounce lasers off of these laser reflectors at the moon.
Yeah,
I'd like
they were
somebody
able to bounce lasers off the moon before they left.
They won't tell you that part.
Yeah.
That
But
they
if
did
you move the
before.
laser a little off the retroreflector, you get a much lower signal. So
Really,
what's
can you
causing
can
that?
you
So
verify-
you
can
admit that you
verify
can shoot a laser off the
Let's
moon.
get what's his name? What's the guy with the big lasers on YouTube here? Can't think of his name. Styropyro. Let's get Styropyro involved. I want to shoot lasers.
I was actually a long time ago. I was with some buddies, and we were working on a laser project with crazy ideas of using refraction in the clouds to create a visible signal so that you could transmit data long range by using a high-powered infrared laser. And at the point of refraction, you would actually be able to point a lens at it and collect really low latency data, which could transmit communications simply by looking in the direction of where you know the laser to be. So to the human eye, they see nothing. There's no way to intercept a radio signal because the beam of light shot straight in the sky. You then use a lens capable of detecting infrared, and it can give you low latency data so that you can communicate over a battlefield without someone intercepting your signals or satellite communications.
Well, speaking of World War II, Austin, explain how the Germans were able to steal signals.
This is a big.
Listen to this, Tim. You'll like this.
It's a big flat Earth proof. So, in World War II, the Germans developed so what they would do is they would fly the planes in blind, right? So no one knew. So it would be pitch black, and they would use radar beams to guide the planes. And so they would use intersecting beams, and they would know, okay, this is where I need to go. That way, no one knew where they were at. Then they thought, wait, we can do this kind of in reverse, and we can attack this way. We can show the plane where to drop the bomb if we actually intersect the beams. Once it gets there and it has a coherent signal, it'll know, oh, I dropped the bomb. So this was actually proposed to the British, and they turned it down because like, no, this won't work because the radius of the Earth is going to block those signals way before any tactical position. The Germans did it. And the Germans did it from 400 or 500 miles away. They intercepted these two signals, and first attempt just destroyed a warehouse that was manufacturing engines and stuff. And it should have been blocked at roughly 30 miles, according to the globe Earth math. And they sent it hundreds of miles and successfully blew up the building. I'm definitely open to some type of explanation for that because that is not physically possible, and it has to have specific coherency. So beams obviously they spread out and diverge as they go further, but it had to have a maximum width of a few hundred yards intercepted in a very precise way so that the plane could blow.
Now here's the other issue. The Allies claimed that their ability to bomb so accurately at night was because they ate carrots. You guys know the story?
No.
A rumor was spread that there was high carrot consumption, which improved their eyesight, and that's why they were so good at hitting targets at night when it was actually a technological development they didn't want the Germans to know that we had. So my point in this is the challenge, obviously, for all of these conversations goes back to just like the standard philosophical, are you just trusting something you read? And so how much of it is I did a study that could not confirm X, which is very limited data because you have to try and replicate it multiple times. And then, you know, depending on your view of modern science, you'd want some kind of peer review. So if you're telling a story about how the Germans did this thing, it's like, or they lied. Or the
Sure,
Germans
they
lied.
blew up the warehouse at night somehow, right?
Yeah, they had a spy, and they didn't want the Allies to know that they had a spy who gave them accurate information and timing and telemetry, etc.
Or they stole the signal. But Tim,
Yeah,
you like
so
this
the
one.
challenge is that there's good reason for one of the questions about aliens. Why does the United States claim? You know what? These hearings where they're like, there are aliens here, and then you had that one guy in the '90s. I can't remember his name, but he's on Joe Rogan. Who's talking about how he saw aliens. The purpose of that is actually relatively simple. They could be trying to convince our adversaries that we hold secret technologies that could destroy them, that they can't figure out what we have. So for the Germans to say like, oh, we did this thing with radar, the U.S. is like, but that's impossible. We can't figure it out. The confusion and the fear in your enemy is valuable to lie. So those stories could be, who knows?
Sure, but if we get to the point where we all agree, if we were to agree that would falsify the globe if real, now we've made like fruitful progress, right? Because then we'd be like, well, let's try to imitate this. Now, obviously, imitating that's not going to happen, really.
Occam's razor would suggest the Germans just lied.
Maybe it's actually acknowledged. It's acknowledged by even the Allies that they use this technology, and I'll even go a step further and tell you the supposed explanation as to how it happened on the globe. And this is all anyone's ever said, is diffraction, that basically the Earth would block the beam and then it would fill back in behind it, and it would keep doing that. The problem is that wouldn't maintain the coherency needed to intercept the beams, and I've never got a next rebuttal. So, good point. Obviously, I wasn't there. I can't verify that. You know, I've gone and tested the Earth myself. That's actually my primary reason.
You believe the Earth is round.
Yeah.
So what is how do you feel about it?
I don't know. I have never heard this before, so I'd have to investigate it.
What-
Your point, if I can elaborate on your point, that they could have lied, it could have been this, could have been that, and we don't know. Okay, so let's go back to this Earth fixed or not fixed issue, and there's another experiment that was interpreted in two different ways by many scientists, and that was the 1887 Michelson Morley experiment. Very simple experiment. You probably know about it, right? Okay, so if the Earth is moving around the sun at about 20 miles a second, and you shoot a light beam in the direction that the Earth is moving, that light beam should be impeded by space. At that time, they thought ether. Okay, so space is a something. It's not a nothing, because nothing does not exist. So it has to be something. Something's going to impede that light beam, and they could tell you by how much that light beam would be impeded. They can figure it out, okay?
The speed of the Earth.
Yeah. So here's the problem. It didn't show any resistance to the light beam, space, okay? They couldn't measure anything. It measured just a little bit, but not enough for an Earth going around the sun, okay? So the obvious interpretation of that experiment is, well, the Earth isn't moving. That's why there wasn't any impedance of the light beam, okay? Well, we can't have that because we're all Copernicans, you see. We believe since the time of Copernicus that the Earth does move around the sun. So there has to be another explanation. This is where your lie may come in, you see. The explanation is there is no ether, and the light beam couldn't be impeded because the ether doesn't exist, which is a la special relativity. That's Einstein's special relativity in a nutshell, okay? So here's another way to explain the same experiment as opposed to a fixed Earth. Which one's correct? Okay, so we went on for a while where, okay, Einstein has to be correct. We all want to be Copernicans. We don't want to kiss the feet of the Pope. So we'll take his explanation, okay? And then 10 years later, Einstein comes back and tells us, well, the special theory really doesn't work all that well because it's in a pristine environment. You have no inertial forces, you have no ether, you have no nothing. And that's why the light beam can go the same speed. But what if we have a big universe where we have gravity, we have inertial forces, we have heat, we have all kinds of things that could impede that light beam? And so guess what? Einstein took back the ether that he had gotten rid of in the special relativity theory. Okay? So if you take back the ether, then how are you going to explain Michelson Morley?
Yeah, and Wikipedia will tell you that that's Michelson Morley disproved the ether, and everyone repeats that script.
Yeah,
They don't
so-
know
but-
what he
but-
just said.
so-
You think there is an ether?
Yeah.
Overwhelming.
Definitely.
But what is it? Could you explain what it is?
Yeah, it would be, there's many things it could be. It could be an electron-positron dipole, because they found that in the 1931 Anderson experiment. It could be Planck particles at 10 to the minus 35 meters in length, because we know that space cannot be nothing. It has to be a something, and if it's going to be a something, it has to be the smallest something that's possible to exist as matter.
So so does that mean that if it's Planck particles or whatever, there's just like an infinite, not necessarily literally infinite, but just like a ridiculously large sum of all of them within and around us all the time? Or
Everywhere,
you're saying
yeah.
in a vacuum?
Yeah, because the atom itself is 99% empty space.
And that empty
Gotta-
space you're saying, though, is going to be something.
It's going to be something.
Yeah, and Tesla
Okay.
actually said that he believed it was a substance that was tenuous beyond conception, meaning like thinner than an actual homogeneous medium, basically. That it's like the air is right now. Only it's an additional medium, but it's so thin that it's like beyond conception.
Yeah.
And a fascinating thing that I love to bring up, and we brought up on Timcast IRL 2 days ago, was the discovery of air as matter, the eventual discovery of air as its weight, and the eventual discovery of the composition of air. That early humans didn't understand that there was actually a matter in front of them.
Right.
They thought there was nothing.
Yeah.
And then, as the story goes, there's a couple stories. One of them I just read the other day was that they flipped a bucket upside down and put it in water, and water wouldn't go in it. And they were like, there's something in there. And they're like, hey. And then it wasn't until, unless all of our understanding of science is wrong, which, I say a lot, was the 1700s with, who did we look up? He actually figured out the weight of air. And then so it's fascinating. It's fascinating because we take so much for granted. Like the discovery of zero is fascinating in mathematics. Early humans didn't conceive of that in math, and how it behaves and how it affected our understanding of the universe. So, just simply put, to wrap that thought, there's so much we don't know that would dramatically change everything we think we know about the universe, which could happen as soon as humans discover another concept. Or, zero is kind of fascinating because it's so obvious to us now. It's just ingrained in us. Yeah, zero, right? But there were generations of civilization where they were like, huh? And then somebody went, dude, it was an Indian guy, and he was like, look at this. And then they were like, whoa, that makes sense. Cool stuff, huh?
That's an important point, right? Is this like dogma is so antithetical to science or discovery and knowledge. Throughout all of history, someone's made a random discovery that shattered the current paradigm, right? That's what happens. So every time the mob role ridicules those who point out that there may be alternative or the evidence doesn't match it. Until that happens, everyone switches overnight, right?
Let me ask you, how do you explain gravity?
Gravity goes right back to the Planck particle, I think. Now, there's a lot of theories out there about gravity. But if this book is 99% Planck particle and, whatever paper's made of.
But you just
wood
mean
pulp.
ether.
You could say ether. I mean, we
But
could
do
use
you
that
think
term.
it is Planck particle?
I think, yeah, it has to
Okay.
be the smallest possible material substance that nature allows.
Or thinnest.
Because if it's not the smallest, then you're going to have something there between the particles that can't be nothing, has to be something. So now you're going to have to go back to the smallest possible particle and the smallest possible distance. This is all already known in quantum mechanics, okay? So if everything is filled with Planck particles, then if you have matter made up of, protons, neutrons, electrons, and that can exist in a Planck particle medium, then it's going to create a vacuum. Okay? You need me to elaborate on that?
Yeah, we'll explain. You're saying
Okay.
we're being pulled down by vacuum forces, or?
Yeah, that's pretty much what it is. It's a vacuum force because you have matter impeding on the Planck particle, and now the Planck particle isn't at its optimal density. If it's not at an optimal density, and nature abhors a vacuum, then it's going to try to compensate for that lack of optimal density, and start pulling. Whatever's out there, it's going to start pulling.
So do you think that there is a firmament and there's no space then?
See, now this is another issue about the firmament that we need to know, which is a lot of the theories are based on the fact that the firmament is a solid thing. That's why you have the picture of the dome. That's what you get in Genesis chapter 1, verses 6 to 9, that it's a solid thing.
Yeah, it looks like a glass barrier, right?
Yeah.
Figuratively.
Yeah, but whatever it is, it could be gold. Who knows? It's solid.
Radiation.
Well, that's not solid.
No, you're saying the presumption is that it's solid.
No, because that's what the Hebrew word means.
Oh, really?
I mean, that's why you get that's why you get the word firmament. It's firm.
Yeah,
okay?
but in
That's where
Greek it's
comes from.
stereoma, which means solid.
Yeah, but there's another facet to this Hebrew word, rakia, and you get that in the second part of Genesis 1 when it starts talking about the celestial bodies. It says God made the sun, the moon, and the stars and put them in the firmament. Mm-hmm. Okay, well, how can that be if it's solid?
They're wrong.
No, you got two meanings for the firmament. You got one that's solid, and you got one that's ethereal. And that's where the celestial bodies can fit in. And if you follow the meaning of firmament, the rakia or raka, it's another derivative of it, throughout the Old Testament, you see those two meanings.
So let me try and get the gravity explanation then. So
Well, gravity's fake, and this is how we know, because it's all buoyancy and density, because this I can prove. Why does a balloon float, Tim? Is that
Archimedes' law of displacement.
Which was discovered long before gravity, right? I mean,
Oh, yeah.
but we put the little g in there now. So because gravity comes from gravitas, which means heavy. So it just means that objects are heavy; they have a weight. As to what causes objects to have weight, that's the real question, right?
So
being asked.
right. So the issue then would be, I'm trying to understand, and maybe I'm getting it wrong. The Earth is massive, and with Planck particles occupying 99% of space, there is a massive vacuum that is the Earth pulling everything towards it.
Well,
to balance.
the Earth also has Planck particles in it.
That's what I mean.
Oh, okay.
So the Earth is effectively this gigantic structure with massive vacuum force pulling everything around it to it.
That's right. That's right. And you
What's
can
what's the conventional gravity theory of gravity?
So, and to be clear, I'm not a physicist. I'm just an amateur astronomer who enjoys looking at the stars.
Are you a doctor?
I'm a doctor of neuroscience.
Then we'll say doctor, but keep that part quiet.
You're a doctor.
Yeah, no, I don't know much about theoretical physics and about what causes mass to have gravity. That's outside of my wheelhouse, to be honest. But
Well, it's the theory of relativity. It says that gravity is the bending and warping of space. It's the effect of the bending and warping of space-time, and that it displaces the space-time, causes a gravity well, and basically objects fall inside this well. Back in the day, it was Newtonian, which is that matter inherently has some property that pulls things to it. And actually, Newton said that he couldn't understand it. It must be God doing it. And most people won't talk about that. He just straight up said God must be doing it. He threw his hands up. He said there had to be an ether if it existed, because there had to be mutual contact between the bodies and stuff like that. But this is interesting, because people will say like, "Hey, stupid flat earther, what's gravity?" Right? But the mainstream model doesn't have a viable model for gravity.
right, they
It's
don't.
not even remotely close.
Is the flat Earth? I've read this, and it may not be the actual one, but what I've read was that the Earth is moving upwards.
No. Total straw man. Total straw, insane straw.
but Austin, you don't believe in relativity, right? I mean, you don't believe that the sun is 93 million miles away. You don't believe that.
You're conflating things. So I believe in the principle of relativity. I don't believe in the theory of relativity. It's ridiculous.
What's the difference? What do you mean?
Yeah,
by
what's-
it?
Meaning that things are relative. Like I can be moving in a car and it looks
see.
like the tree's moving. Obviously, that principle is real long before Einstein was even a thing. But the theory of relativity is
As a matter of fact, Bellarmine used that against Galileo, the theory of principle of relativity.
principle, exactly. So but gravity doesn't work at all in the mainstream model. It's such a misnomer. In 1933. Fritz Zwicky looked at a coma cluster, so it's like a cluster of galaxies all together. And to keep the galaxies together, there had to be a certain amount of gravitational force, right? So gravitational field had to be certain strength, and it only had 1% of the mass needed based on the gravitational prediction. Gravity was off by 99%. To this day, it's off. Dark matter is what they called it. At first, they called it missing mass. Then they just plugged in the value to fix it, and now it's called dark matter, completely undefined. It's just invisible, effectively, is what dark.
Yeah, it's like we can't detect what it is. We don't know what it is, but it clearly has some kind of gravitational effect on.
Yeah.
We can see gravitational lensing in
Right.
galactic clusters. We can see that
What
we
does that have
expect
to do with dark matter, though?
because galactic clusters have a lot of dark matter, and so if you look
What
at
is dark matter?
if you look at galactic clusters, they seem to be lensing light, and if you tally up the mass that you expect to see in those galaxies based on the amount of light that you're getting from the galaxies, it doesn't add up. It doesn't seem.
Wait, it doesn't add up according to what?
So Wikipedia, our best friend, says dark matter is a hypothetical form of matter that does not interact with light or other electromagnetic radiation. Dark matter is implied by gravitational effects, which cannot be explained by general relativity unless more matter is present than can be observed. Now that's fascinating because that sounds to me, and I hate to say it, but it sounds like they have this theory and they go, okay, well the theory can't explain this thing, so something must be there then, I guess.
Exactly. It's almost religious. So obviously,
But I'm not saying it's wrong. It's like Sudoku, right? We figure this is what's there is thing here. You know, we look at the numbers and we say 2, 5, or 6 must be in this space. So my point is simply, I think it. Obviously, the point of dark matter is that we don't know, and based on what we think about general relativity, we are plugging something in we've not yet discovered.
and
Well,
it's been
actually, it
over a
goes back
century almost.
further. It goes back further than that. What they're saying is that F equals ma, which was Newton's formula, okay? Einstein's formula is G equals 8 pi tau, which is almost identical to F equals ma.
So what does F equal ma mean?
Force equals mass times acceleration. So m is the mass. So if you get these galaxies are rotating 10 times faster than F equals ma will allow, what you have to do is increase the m of the equation. The m is the dark matter.
So you said you were a physicist?
I was a physics major.
Physics major.
Yeah, but I don't have a degree in physics.
I had a conversation with a professor once where this was 20 years ago. We were talking about string theory. I was reading a book on string theory and dimensions, and he said something like, yeah, well, now it's M theory, and there's another dimension they just added. And he was like, the issue is that it seems sometimes like a lot of these guys have dedicated their whole lives to the research of this unified theory where they're trying to figure out what's going on, and to learn that 30, 40 years of research may have been in the complete wrong direction would be emotionally shattering to these people. Yeah. So instead of saying maybe I'm wrong, they say add another dimension to make it work.
Exactly. Yeah. Same with relativity. Actually, PhD physicist Robert Bennett, you know him. Shout out to him. I talked to him quite a bit. He said basically it appears you're just gonna have to wait for some of them to die. You know, like that's actually what I was told. This is a really fascinating conversation because I was reading a book on a couple different books on quantum theory and things like this, and what I was told was major shifts in science happen when generations of scientists die.
Yep. Because
they over a lifetime they develop a view of the world that they're emotionally attached to, and that's not an insult. And it's not to say that they're irrational or angry. It's that they see the world in this one way and they see all these pieces, and it's hard for them to turn around and look at something different. Someone who's young comes in and is navigating the space from a different perspective, and they might notice something. So when the older generation dies, I mean, this literally explains geocentrism and heliocentrism. There's a generational shift, and then people now viewed the universe and it became mainstream conventional that we orbit around the sun. When one generation goes, the new generation believes something totally different.
Well, this is a major part of it that people need to understand. It's the Copernican principle. It's the idea that the Earth doesn't.
That's what your movie's about.
Yeah, that's what the principle is referring to. Yeah, the Earth doesn't occupy a special or unique position. This is like a philosophy. It's that the idea that the universe is so huge that it's illogical to think the Earth.
Let me give you a good example of how a scientist can be so biased when he's looking at that so-called evidence. Edwin Hubble, you've heard about him?
Yeah, he has a telescope named after him.
Yeah. Famous guy, famous astronomer, one of the most famous. We cover him in the movie, and in 1929, he used the Mount Wilson telescope in California, a 100-inch telescope. I mean, it's as big as this table. You could see galaxies for the first time in human history.
Wow!
So he saw them, but he saw something peculiar in these galaxies, and that was they all had a redshift of the light beams.
What year was this?
1929. Okay, and he wrote a book in 1937 describing all this called the observational, that's the key word, observational approach to cosmology. Okay, what do we see out there? How do we interpret it? Okay, so he sees the redshift of all these galaxies, no blue shifts. How do we, I mean, this looks like the Earth is in the center of the universe. He says
So
it in the
in
book.
every direction, you see a redshift.
Right.
So can you explain redshift?
Yeah. When light travels, it can be disturbed, taken energy from it. And the light you see is going to shift more to the red end of the spectrum than it would to the blue end of the spectrum. Now, you know what light is because you see a rainbow. You see 7 colors. So it'll be like seeing a rainbow with more red than usual.
And so what does that imply?
That implies if you get redshift from every angle you're looking at, okay, and you get no blue shifts, that means we, the observer, have to be in the center of it all.
So I got a riddle for you guys. You are in a cabin with how does this go? I'm going to ruin it. With 4 windows, and I'm ruining it. Let me look it up.
Let me finish the story first.
Finish the story.
Okay. So he says, but we can't have this. This is horrible. This is horrific. We would only accept this as a last resort to explain the phenomena that the Earth is in the center. So what do? Well, here's what we do. We get rid of the center. We get rid of the center, okay? That means we get rid of Euclidean geometry, and we make a balloon of the universe. A balloon has no center, just has a plastic surface, okay? We put the galaxies on the surface of this balloon, and then we blow the balloon up. So it gets wider and wider and wider. What's going to happen? Each galaxy is going to see the other galaxy move away from it, and what's it going to see? Redshift.
So you're in a house with 4 walls facing south. You step outside and see a bear. What color is the bear?
What?
You are in a house with 4 walls facing south.
Okay.
You step outside and see a bear. What color is the bear?
4 walls facing south.
You step outside and see a bear. What color is the bear?
I don't know.
Anybody?
I believe it's 4 walls facing. Oh, yeah. Okay.
What color is the bear?
It's not white?
Well, okay, it is white because you're at the North Pole.
Exactly.
The walls are facing south.
All right.
So that's what this reminds me of.
Yeah.
How could it be that your house is facing south in every direction?
Yeah.
You're clearly on the North Pole.
Yeah.
The only direction you can go from there would be south.
Perfect. I'm going to use that.
And so the riddle is, what does a bear have to do with my house facing south? But if you actually break it down, you're like, how could your walls only face south? You're at the North Pole. The only bear that you're going to find up there, I don't even know if polar bears are at the North Pole, but whatever.
Okay.
That's
so
the
let me
joke.
just put the finishing touch on this, the icing on the cake. So the guy, he says, we expand the balloon. You see redshift. We don't have any more Earth in the center. Problem solved. Okay. So Father Lemaitre comes along, Belgian priest, Catholic, and says, okay, let's do this. Let's reverse the expansion and make it go down to what happened at the beginning. And you can't define what happened at the beginning. That's why they call it a singularity. But they're figuring it took 13.78 billion years for it to start here, and then expand to the point where we see redshift everywhere, you see. And that's how you get out of an Earth-centered universe, by rearranging the universe into a Riemannian 2-dimensional balloon instead of a Euclidean geometry with a center.
I think the argument they make is that the universe is expanding,
yeah.
and we are not in the center of it, but is expanding. It's still expanding around us. Thus, you will see a redshift regardless.
Yeah.
So if you know the way you're describing it is if you're on this balloon, even if we were on the leftmost surface of it, as it's expanding, we're going to see things even right next to us redshifting as they're moving away from us.
Yeah, but we're going to see blue shifts too. That's the issue.
How would you see a blue shift?
Because you're closer to the light now, and it's not going to have the same kind of stretching that it had when you were in the center.
But it's still moving away from you. So no matter where you are on an expanding surface, everything's moving away from you.
Very slowly. So you're
Right.
not going to get an intense redshift. It's going to shift to the blue end of the spectrum now.
Or I don't think it wouldn't shift to blue. It would just be less red.
Sure.
It would be
shift to blue. It has nowhere else to go.
But if it's moving away from you, isn't it still going to be red?
It's moving slowly away from you because you're near the edge.
So why would that? So even if it's moving away from you, it could have a blue shift.
No, it'll shift more to the blue end of the spectrum. It's not going to have the same amount of redshift. You
I see what
we're
you're
talking
saying.
about degrees here.
Yes,
This
yes,
has
yes,
actually
yes.
all been disproven too. You can look up like all the redshift anomalies. There are things that are way closer to things that are super far away. They have way more redshift though. Right.
But so the universe is expanding.
No.
No, that's the philosophical assumption required to get rid of the idea the Earth could be in the center. Hubble actually said it was intolerable and horrific. It shows that it implies the Earth's in the center, akin to what everyone thought throughout mankind. But we're going to avoid that at all costs.
Well, so if the universe isn't expanding, what explains the redshift?
There are many theories, actually.
There's a very simple one. When you have a galaxy out there and the light beam leaves the galaxy, the gravity of the galaxy is going to pull on that light beam. And it's going to turn it into a redshift.
It's going to slow it down,
Yeah.
effectively.
Yeah.
And there's something called the tired light theory, which is the idea that it attenuates proportionate to distance. So similar to how like a laser can't go as far through water as air, it attenuates, it gets absorbed into the medium. So that would do it. There's also
Like light is passing through things that interfere.
Yeah, it could be it. That was the first theory.
Yeah, and I actually think that it's electromagnetic retardation. It's actually been shown that.
But you can't say that it's
you don't believe that galaxies are millions of light years away to begin with.
That doesn't matter at all.
It does.
No, it literally doesn't matter at all.
It does.
But why?
Because you're talking about a light attenuating over great distance. Like, you don't even believe in those distances. Like, how do you even
I don't
know?
believe in the medium either.
You don't believe in ether?
No. Well, okay. So now we're introducing a medium and maybe even another medium. And let's also introduce some plasma because it's been proven in a lab, unlike your belief of redshift, that photons, quote unquote, which I won't get into that. They redshift through plasma.
So you
redshift through
don't
plasma
think you can
proportionate
replicate
to the medium.
redshift? You don't think that you can get Doppler shift on a spacecraft traveling out from the Earth?
Yeah, of course, with frequency, and then you get into like sound and light, and what's the difference between the two?
You said you couldn't recreate it. Like, we can test redshift.
No, what I said was your theory has been proven wrong, and the reason it's been proven wrong is because the observations don't actually match the theory. For example, quasars, supernova, and I could go on. When these are observed significantly closer to Earth in your paradigm, there's way more redshift than things that are further away. Also, the redshift isn't.
Wait, you're saying that the quasars are further away than the galaxies?
I'm saying that their model doesn't actually add up. That it's just based on.
Yeah, I know, but you said it looks like it's far away, but it isn't. Now that's the theory that goes along with quasars being way far away and galaxies being rather close to us. And Halton Arp, you know.
Yeah, Halton Arp. That's who I was about to plug.
He's the one that said, no, that's not what's occurring.
Exactly.
What's occurring is the galaxies are creating the quasars, and they're right next to the galaxies.
Right.
And he actually showed filament between the two.
Yeah.
So the whole theory that the quasars are way far away and we see a greater redshift is false.
Yeah, but because they just had to assume that, right? Because it had greater redshift.
Yeah.
But like Halton Arp, this is a perfect example of what happens. People call this science. It's basically a cult, though. Halton Arp was like revered almost, like completely respected astronomer, like world renowned, like had things named after him. And he comes out pointing out that redshift doesn't work. And he ends up writing a second follow-up called Seeing Red, which is a play on how he's like getting angry because he's being blacklisted. He gets blacklisted. He gets the right to actually use observatory telescopes revoked from him because he comes out and speaks out against redshift. That is not science.
Well, it's because it's against the Big Bang.
Yeah, it's a cult. It's a cult. And that's what the Copernican principle is. All the evidence shows the Earth is in the center. And no one knows any of this. It's been omitted from the consciousness of people. And then you get into the physical test, it just definitively proves it.
I want to say something here that is a dimension of this that deals with my major study, which is theology. And that is this, that if the Earth is in the center of the universe, that means somebody had to put it there because it's not going to get there by time and chance.
Is that, would some argue then that you are incentivized to push theories towards the idea of a geocentric universe?
I would never do that.
Well, I would say
what I'm trying to say is I would go by the evidence. If the evidence supports that theory, we went through Michelson Morley, we went through Airy, we went through the cosmic microwave background radiation, we went through Hubble's Big Bang universe, where that came from. That's enough for me to say I don't have a bias because the evidence supports what I just said.
Now, Tim, can you flip it around, though? Now, flip around what you just asked him. Could it be said that people have a bias against the idea of intelligent design, therefore exclude the possibility of geocentrism? Because that is very clearly what is happening. Stephen Hawking literally says, I can't disprove geocentrism. I reject it on grounds of modesty. Hubble calls it intolerable and horrific. Lawrence Krauss says it's coming back to haunt us. The Copernican principle is coming back to haunt us in his film. There is a bias against intelligent design, similar to how modern academia is overwhelmingly drowning in liberalism.
Yeah.
Well, modern academia in terms of science is drowning in atheism. And it actually implements philosophical bias at this point, and they can't have a creator. Well, I would say that even in the mainstream model, you still need a creator, right? But it doesn't matter. The point is, like, you see that every atheist I've ever talked to, I said, so if the Earth were in the center, let's say hypothetically, do you agree that it had to be put there? None of them deny that it drastically increases the chances of intelligent design at the least, right? Because if it's in the center of the whole universe.
And in Scientific American, it says 90% of the major scientists are atheists.
There you go.
So there's your incentive.
Yep.
Tim, I sent you a video because we were talking about so much scientific stuff. I want to talk about maybe a little less scientific stuff. I sent you a video on X where you're from Chicago, and you know this, Tim. You can go out there, and this is because I got to shut down Bob, even though I like you, Bob. If you go out there, if you pull up that video, you pull up that video. If you look across Lake Michigan, Tim, you can see the entire skyline of Chicago. I sent it to you on X.
Let me.
What elevation, though? How high are those dunes?
You're talking about being able to see it. How high?
I just want to say real quick, there's this expanded flat Earth map that makes me wish the flat Earth stuff was real. You've seen this, I imagine, right?
Yeah.
The world beyond the ice wall. Mm-hmm. The idea being that the world as we know it is surrounded by this wall of ice, but outside of it are advanced civilizations.
Yeah.
And then there's another ring, and I'm like, that'd be so cool.
That would.
It's like there's like an advanced. So there's Odin, the walls of Asgard, the scorched wastes, Osiris, Nemo, Lemuria, and it's like we are trapped as sort of trapped in this zoo around this ice ring. And if only we could penetrate it, we could get to the great land of Aten and Atlantis.
Well, General Admiral, or is it Admiral Byrd? Was it General Byrd or Admiral Byrd? It doesn't matter.
Admiral.
He went to Antarctica. He was like the first explorer to really explore it. And he said that there's enough resources in Antarctica to supply the whole entire world. And so there is stuff in Antarctica that doesn't make sense that we don't know about.
Major problem for flat Earth, though, if you look at that map, Tim, you've got South America pointing one way, you've got Australia pointing another way. How are they both able to see the South Celestial Pole looking south?
At different times?
To be fair, I will say this.
Why do you always omit that it's at different times?
The flat Earth theorists do not believe this is a real map.
No.
It's a fantasy.
This is the thing, right? There's a model that claims to know exactly what the Earth is, and then there's a group of people who heard the insanity that people think it's flat or whatever. So they just went and challenged it and looked into it, and they've suspended belief of the globe model. This definitive flat Earth model thing is not popular within people who would say that they are flat earthers. We don't know. We can't even privately explore it, right? The empirical measurement shows that the Earth is not curving at the rate that they say, and we don't need Chicago. You can see Canigou Mountains from 160 miles away.
Which the globe predicts.
It literally does, and it
literally does. It literally does. You can go check it out.
So is this
the elevation of?
Is this an inaccurate depiction or?
Inaccurate. Straw man.
What's wrong with that picture?
Well, just like a disc in space. I don't know what.
It's just the demographics of the continents and how far they are away, and the seas and everything. That's pretty accurate.
It's pretty accurate. When you get to the south, it's interesting because we actually dug into the GPS data, and in the south they make what's called meridian corrections. So they actually are pulling out land, like distance, out of the meridians, in between the meridians. Which
you have to. Whenever you flatten a globe, you have to do that.
Well, what I'm saying is, if it's really a globe, right, then we wouldn't have to do that for the actual raw GPS data, but they do. They also make SAGNet corrections, which is another falsification of relativity.
Well, that should tell you that the GPS is based on a globe Earth.
Well, of course, but the point is that they have to run it through corrections to get the final longitude output, which shouldn't happen. And this is what I want to point out, though. Like, there are physical tests that show that the Earth's not curving at the rate that they say that it is. So the Earth is measured flat. I wonder if we could all agree on this, that flat Earth is actually the default position, because it's always flipped around, right? Well, the horizon's horizontal. When we build things in civil engineering, we actually use plane survey. We do it flat. We connect horizontal. So bridges, runways, railways, canals, when we fly planes, all aviation, we have to treat the Earth like it's flat. Sea level, elevation is a distance above that. Whenever we actually got the latitude system, we took elevation angles to Polaris from a flat horizontal baseline that extended all the way to the zenith.
That doesn't prove anything.
Well,
it just proves that map works.
Trilateration only works on the globe, though. You can only get your position from the globe. Like you have to actually know the orbits of the satellites.
But there is no satellites.
I have a
No, there are satellites. Satellites disprove heliocentrism, and the actual path is nothing more than a projection. So
I have a quick question. It was very rudimentary, not going to get into deep science or anything. I once flew to New Zealand, and I'm looking at these flat Earth maps, and I'm like, I can't quite explain the path of the flight as it pertains to the flight I actually went on. So I know which direction we left from the airport, and I know I did not fly north or westward.
you're over water the whole time? Most
Yeah.
of the time? Yeah.
And so that would imply that after we flew south beyond the visual, the ability to identify any landmass, the plane then hooked right. So it implies that when I flew from New York to Los Angeles to New Zealand, and I got these maybe these maps are inaccurate representations of what flat earthers believe, but if I left from Los Angeles and we started flying south, which we did, as soon as we left the visual area so that no one on the plane could identify it, the plane then turns right. So it flies straight down and then hooks right instead of just flying straight to New Zealand. I don't believe that happened.
Well, planes are always making corrections based on cardinal direction. So you're not going to be able to tell in a plane, but
I can tell that we didn't fly west or north. And so when we departed, we were flying south.
If you left South America and went to New Zealand, you could go there on a globe map straight to New Zealand. If you turn that into a flat Earth map, the flat Earth map would require you to dip down to make like a semicircle and then go up to New Zealand. That's a fact.
well, yeah, there are many paths that make more sense on, like, say, the azimuthal projection than the globe, and they claim all kinds of things. They didn't stop for gas or whatever. And I'll make it very clear, actually, I don't claim definitive projections. If we've been misled about the nature of the Earth, which I think the evidence is overwhelming that we have been, it would be very naive to think that we have a perfect depiction of the very thing that we were misled about. Of course we don't. Now, in the north, or 90% of the world population here, we have a better grasp of it, but it's just a projection thing. And bringing up the satellite thing, that's kind of like a misnomer that like satellites can't exist on a flat Earth. Actually, satellites, for one, disprove heliocentrism, because they actually have to account for inertial forces. They account for centrifugal forces, which are considered fictitious and pseudo forces in your paradigm. They can't exist. So if there are actually satellites being put up there, they're accounting for the angular momentum of a rotating universe around a stationary Earth with inertial forces, centrifugal, Coriolis, and Euler forces. Those can exist in your paradigm. They don't exist in Newtonian mechanics. Those are forces external to Newtonian mechanics, and they don't exist in Einstein. So just point that out.
Whitsitt's trying to...
Satellites are actually, I love them. This idea that I'm scared of satellites. Well, I see Starlinks. I watch mini launches. I don't have a problem with it. I have a Starlink. You know, I haven't set up the internet, but I have one.
How do they stay up there?
Well, that's the equations. The physics and equations say they're using the spinning universe. That's what is factually in the equations. It says that it uses centrifugal force. So like if you had a ball tied to a rope and you spin it, right, it's going to keep going in a circle because you're pulling it, but the ball has a tendency to move out away from you. It's going to keep going around because you're pulling it. That's called centrifugal force. They have to account for this and the real Coriolis force, which is like an inward centripetal force, so a radially inward force, for the satellite equations. According to the heliocentric model, there is no such thing. That shouldn't.
How would they stay above a flat?
They're on balloons. Type in satellites on balloons. I'm telling you, they're
not all on balloons.
They're not all on balloons, but there's satellites that were on balloons.
Yeah,
from
it was called
Samsung.
Say Balloon.
I'm just saying. So
Google
they say
Google
there's
launched
satellites.
a bunch of balloons carrying internet nodes.
Exactly.
So they could float over
I'm
the
saying.
Earth.
So
the
that's not a
military-
conspiracy.
the military
I'm just saying
also
they
has
use
them.
balloons, and NASA is the user.
So
more
Elon's
helium
actually just launching balloons, but putting on
You
a
can
show.
type it.
No,
you
no,
can
I
type in
don't
NASA. They do balloon launches. Literally,
I know.
type in that.
Yeah, they
right.
can do that if it's low Earth orbit. But if you have a weather satellite that's out there at 22,200 miles, you're not going to get a balloon out there.
See, I totally disavow those distance claims, and because the way that they do it, they take the signal and that's cool. So what equation do you use to determine the distance?
Parallax. You just use simple trigonometry. It's basic trigonometry.
Really? So what's the length of your baseline?
Well, let's see. For space station, it was 760 meters.
760 meter baseline to determine the distance to the space station.
Yep.
Okay, and so you're saying it's impossible for the ISS to move over a plane?
What does that have to do with me measuring the distance? You can assume it's a plane. You can assume it's a globe.
Well, earlier you said trilateration was impossible.
Trilateration is about you finding your location. I'm
Right.
talking about measuring the altitude of the
Which
space
you need
station.
your location. So that you need your location.
I just know the baseline.
Right.
Yeah.
Okay. So you need your location. That's the prerequisite. So the point I was making is I don't believe when he claims something's 22,000 miles away. I don't believe that. But he can, I don't.
The moon
right?
is to 240,000 miles away.
Yeah, see, I definitely don't believe that. And but this is the thing. The way that they get the distances, they actually use, of course, the equation for speed, and they assume the medium, the propagation rate of light, and they get how long it takes the duration of signal to get there, right? And then they plug it into the assumption of the speed of light relative to the vacuum, and then they're going to supposedly get their distance. I disavow those assumptions. I don't think that's true.
Well, you guys are all wrong. The Earth is clearly hollow and flat. It's a donut.
Vice is stupid. You know that.
We're in a donut magnetic field. I want to answer the firmament thing, though, the idea of putting them inside the firmament. All the early church fathers even, but like many people throughout all of like biblical history, they said that there were layers to a container. A physical container had layers, and the sun, moon, and stars are inside those layers of the firmament. And in fact, that they're specific to layers, meaning like the sun and moon and the stars are in a separate layer. So that would be how that's explained.
It's not explaining it.
Why not?
Because the Hebrew word is beirakia, which does not mean in or inside, like you're trying to say. You're trying to say that somehow you have the dome, and then there's the inside underneath the dome.
There are layers inside of it.
Yeah. Okay. That's
Multiple
what you're
domes.
trying to say. But that's not what the Hebrew says. The Hebrew says it's in the firmament.
Yeah.
Okay. So if the definition of firmament is solid, how are the celestial bodies going to be in the firmament? Not underneath, because there's a lot of ways in Hebrew to say underneath the firmament.
Well, they're within the solid firmament.
And
I think
wait a second. And there's a lot of ways to say that the celestial bodies are over the firmament.
Well, they're not above or
In
below
Hebrew.
because there's layers. They're within it.
the easiest way to
Yeah,
understand.
but you can't have that if the firmament's solid. That's what I'm trying to say.
But ice and water can go from solid, so maybe it could change.
No,
Well,
there's
solid is a
layers
solid.
to
It's
it.
not water.
I think the easiest way to understand the firmament is for anybody who's ever played World of Warcraft, and you try and go too far south, and your character just keeps walking into what's in
There you
the
go.
wall.
The best argument is that the physical antecedent for gas pressure is a container, right? Because the gas pressure would fill the available space. Second law of thermodynamics, entropy increases. So if we actually had an atmosphere next to vacuum, it would fill the available space. So where people just blindly throw out the word gravity, even though they don't even have a theory that works, and it wouldn't explain it anyway.
But if gravity worked, you would have to admit that an atmosphere would be possible, right?
No, not next to a vacuum. It violates the second law of thermodynamics.
No, it doesn't. It doesn't.
Because how do we have a pressurized
because
system?
You're right. Because they don't the Torr measurement of vacuum in space, they don't know whether it's 10 to the minus 6 or 10 to the minus 17. They have no way to measure it. So if it's 10 to the minus 6, we're safe. The atmosphere is not going to be sucked out. If it was 10 to the minus 17th, yeah. The atmosphere would be sucked out, but that means both your theory and my theory would be wrong.
Well, there's
wait,
something,
hold on,
I
hold
think
on.
there's something containing.
Why can't they measure it? Couldn't you?
They can't get an exact figure. They know it's between.
If we had
10 to the
if we
minus
had
6.
consistent access to Mars, could you?
If we what?
Had consistent access to Mars.
Mars, I don't think would have anything to do with it.
Well,
in my
you're
opinion.
two different gravitational bodies giving
Yeah,
us a
but you're
reference.
talking about outer space.
Right, and
What's
so
the vacuum in outer space?
if Mars can't maintain an atmosphere the size of Earth, due to, what,
Yes, he's saying if you were able to like kind of sit on Mars and make more like calibrated measurements.
what's the rate at which the atmosphere dissipates for Mars if it can't maintain, or the Moon or something?
Well, it's a lot more because it has less gravity.
Right. So then you could measure the baseline by which what is the amount of mass required to sustain an atmosphere. You could then determine if it's not going to hold it because the vacuum is pulling on it.
You could, maybe. But I'm just telling you what the books say.
And the gas pressure the way that we actually even do the equation for gas pressure is a physical barrier, because pressure is the energy or force exerted on the walls of a container. So you need to even have pressure, to even invoke pressure, it presses on the walls of a container.
So, real quick, sorry. The presumption of why the Earth has an atmosphere is because the gravity is holding this matter to the Earth.
Yes.
And for Mars, there is not enough. The gravity is weaker, so the atmosphere is much thinner because it can't hold as much.
That's why Saturn and
gravity's
Jupiter have a much thicker atmosphere because more gravity.
But gas disperses in all directions on the surface where gravity would be the strongest, right? Like gas goes in all directions. You can't just have a vacuum next to a gas pressure on the surface. Gravity is the strongest here. So that's the modern model just isn't true. It defies physics. And I'm waiting for an answer to that. If gravity is the strongest at the surface,
The atmosphere is a gradient, and I've got a simulation that I programmed myself that's on my channel that shows a simulated planet with gravity holding onto an atmosphere. And yeah, it's a gradient. As you go further out, it goes closer.
Yeah, air gets thinner.
Invoked a simulation.
Air gets thinner the higher you go. That's why
Even
people die on
then-
Mount
even
Everest.
then,
Yeah, there's
we have
definitely a gradient.
hydrogen that escapes out into outer space because it's just too light for the gravity to
Oh,
hold
so
on.
gravity picks and chooses between some
No,
of the
it's
gas.
because the hydrogen is lighter than helium.
Why does all the hydrogen not leave?
Because we have enough gravity that it has to seep out slowly.
That's the pick and choose. And in the
No, it's not picking and choosing. That's the physics of
my
it.
question really is: we all agree gas disperses in all directions, right?
So what?
Okay, so gravity's not actually pulling the air down as you're claiming to where it keeps it next to a vacuum. It disperses in all directions where gravity is the strongest.
Well, what is your explanation for gravity?
Well, I mean, I would say that everything for density and buoyancy is a major part of it because it's all just pressure mediating relative to its medium, right? So ping pong, golf ball. But I would say, and this is what I say, I don't speak for anyone else, that everything's electric. And so everything that exists is electrostatic. Literally everything that exists. There's not one exception. Everything's electric. And that's 10 to the 36 power stronger than gravity's even claimed to be on the smallest scale.
Well, how does this explain a balloon full of helium rising in the air?
Well, that's probably more merely buoyancy.
But buoyancy, for instance, when you look at these videos of outer space, they put a balloon, they cover it with water. The water it sits around it. There's no movement in either direction.
Well,
buoyancy requires gravity.
In quote unquote space. Now,
Very
okay,
good.
that's the claim. But I'm trying to explain. Really, what it requires is little g, which is downward acceleration. That's just the effect. We measure how fast things fall. Big G, or the cause of that, is a totally separate thing. I don't deny little g, and I would actually say I know a better cause for it. There's a downward electric current on the Earth. It's based on the electric field has equipotential increase. So every meter you go up, the electric field on Earth increases 100 volts in potential, and that creates a downward electric current. You can actually read Feynman lectures. I think it's 9.1. He explains this. There's horizontal equipotential lines, and it creates a downward current. It's very weak, but it's very.
Does that imply that gravity gets weaker at a distance?
Well, that's what your model would claim as well. Now, I would actually have to get.
Does it?
Yeah, of course. The further away you get from the center of mass. But it would be negligible, and I would actually have to know what the electric field is doing over 50 miles. The most I can independently verify is 30, 35 miles. The mainstream model claims that around 50, 60 kilometers the electric field changes. Well, that's convenient, right? Because that's where we can no longer...
Yeah, but your electric field is starting out there in space, and it's coming down, correct?
Well, I do believe I believe that that's a major variable is that there's tons of electromagnetic radiation coming from the sky, basically coming down to the Earth.
Yeah,
Even
but
Tesla said this.
that implies to me that it's stronger up there than it is down here.
Well, everything goes to seek equilibrium, right? And that's why there's a downward current. You can actually run a generator off of the air.
I think we've shown, help me, that gravity gets weaker the higher you go.
Well, and if it's just electrics, then why do neutrons not float?
Okay, you're saying neutrons don't have any electric properties?
Correct. They're neutral.
They have a net neutral charge. So they're actually, in your paradigm, I don't even believe in this, but they're comprised of quarks. Well, I don't believe in subatomic pseudoscientific particles. It doesn't matter. You're laughing, but I'm about to show you that you don't understand it. That obviously it's made of quarks, and they're made of elementary charges or fractional elementary charges. So they're fundamentally electric.
Neutrons are electrically neutral, though. So why do they not float?
Are they inherently electric?
They are electrically neutral.
See, I just now directly rebutted this. That's the net charge, but they are inherently electric.
If they're net charge neutral, then why would they not float in your model? If electrostatics is just, if that's the explanation for gravity, why are neutrons affected by gravity?
Okay, because this is your model of neutrons and that they're material. All material is electrostatic, and you tried to bring up neutrons, and that's what anyone can ever bring up because they think it has no charge. You're wrong. It actually does have charge. Everything does. Everything's electric. That's the true unified theory. They can't invoke this though because it's going to start to have ether and geocentrism pop back in. But the point is, all molecular and intermolecular attractive forces are electrostatic in nature. What that means is all molecules in the world that are held together in any piece of matter, you name it, rubber, sand, glass, wood, name anything in the world, it's held together by electrostatics.
Yeah, but how does that prove gravity, though?
Well, see, I don't have to prove a replacement for gravity. I'm stating a fact, which is...
Yeah, well, we agree with that. It's all electrostatic.
And think about this.
I have no problem with it.
Well, what is weight? It's weight equals mg. Because you're actually asking me to explain what causes weight, when you ask me about gravity. You have a different idea that everyone's antipodal and omnidirectional, and there needs to be a force pulling me on a sphere that's flying around the sun. I don't believe in that. I'm just going to state the facts that there's weight, and what is it? It's mass times quote unquote gravity, right? Little g. That's how fast things fall. So what is mass? It's volume times density. That's what it is. So then what is density? Density is the compactness of matter, right? So what's the cause of density? Whatever's holding the matter together with a certain compactness, we know that is electrostatics. The actual primary cause of density.
How does that prove gravity, though?
No, it's explaining what weight is. That's all you're asking when you ask, what is gravity? We were talking about weight. Because now I would actually say,
you got two balls, A and B, okay? Mm-hmm. Both are held together electrostatically. We agree with that.
Yeah.
But why is A attracting B, and why is B attracting A?
Oh, well, that's a claim, and you would maybe have to invoke Cavendish. Cavendish is the only thing even claimed to supposedly show that.
Well, it hasn't been disproven.
Well,
so that's why we do it.
So Cavendish is, you can't actually eliminate the variable of electrostatics in that test.
I'm not. I'm just saying the balls attracting each other.
Yeah.
Okay.
Yeah, because of electric variables. So, and this is even well known in mainstream.
Well, you have to prove that.
No, I'm going to explain it. In mainstream, it's actually known. Even when you put Faraday material in between the balls in a Faraday cage and ground the entire system, it still actually has electromagnetic variables that are affecting the balls. This is well known. And then Cavendish actually, right, didn't even account for electrostatics at all, supposedly ran across his yard with a telescope and saw it kind of jiggle a little bit, and then knew the density and weight of Earth by assuming and reifying the sphere. All this comes to is people wanted the Earth to be a sphere, they presupposed it, they built a model around it based on what they saw, then they wanted the Earth to be a sphere that's moving around the sun, and they built a model around it.
If it's true that the satellite can be at a 22,000 miles, I know you don't believe that, but could it take a picture of the Earth and show that it was
absolutely?
Okay.
Yeah, absolutely. But
okay. The 500-mile satellites most of them are about 500 miles above the Earth. They're going around the Earth at a pretty rapid clip, and they're taking pictures of the Earth. Now, what I've heard the flat earthers say is that, first of all, there's no satellites, so there's no pictures taken. And then when NASA comes back with the pictures are a little distorted because the satellite, being only 500 miles up, can't take a picture of the whole Earth, obviously. It can only take a picture of a small section, and then it moves on, and it takes a picture of another section, and it moves on, takes a picture of another section, okay? And then it brings all these sections back, and you have to put them all together. And that's hard to do. Why? Because you're making pictures of a circle. And if you have circles that you're taking pictures of, you're not going to have square pictures. You're going to have peels, like an orange peel. And then you got to put all these peels together. And when you do, the flat earthers say, oh, well, you're manipulating the pictures because...
Well, you are manipulating.
And they admit that's what they did. With
they do admit.
You have to do that because you're dealing with a circle.
Okay, well, it's not proof of anything, right? Like, let's just make sure the audience knows this. The first wallpaper on the first generation of iPhone was the blue marble, right? Does anyone remember the first? It was just the blue.
Yeah.
So everyone saw this picture, right? And I would just assume that's a picture of the Earth from space. It was not, though. It was literally fake. And Robert Simmons, who worked for NASA, who actually did it.
You can pull this up.
You can pull it up. He'll straight up tell you. Robert Simmons, Blue Marble, NASA.gov. And he says, what we did was we take pictures, flat map pictures. We take a bunch of pictures. We put it in a flat map. We compile it. Then we have to transform that. We actually have to turn that into a sphere. We wrap that around a sphere. Then we have to bring in cloud layers and an artist. And my job was to actually touch it up to make it look like what the observer would expect it to look like by painting it. By literally painting it. So the picture that everyone assumed was a real picture of Earth from space all over the default wallpaper is admittedly not real at all.
That's just a guy who made a Photoshop art for iPhone.
Yeah.
For NASA.
That's for NASA.
Pictures don't come in curves. They come flat when you take a picture. So you have all these flat pictures, and now you have to assimilate them all to make the true picture. And you're going to have to add stuff, take stuff away because they're all you have to end up with.
Is it too much to ask for though? A picture of the Earth that's not edited,
which is available every day.
Satellites. How are we going to convince you?
No, I
that
believe
we took
there's satellites. I didn't say there's not satellites. I'm just saying the pictures that they give.
Do you believe there's a satellite out there at 22,200?
I don't know. I mean, I don't know how far. I don't know.
Do you or not?
I don't know.
Okay, so you don't basically.
If it was, why can't we just make a video of it? It's 2024.
We do. It's on TV every night. It's called a weather satellite.
a video. Like, we don't have actual video. Like, if you could have shut this down, you went to the moon, supposedly, just put a freaking camera on the moon, even without sending people.
That's a different topic.
No,
We're
either
not
way,
talking about going to the moon. We're
satellites,
talking
whatever.
I think the
make a
issue
video.
is they're so concerned with sending $250 billion to Ukraine, no one's going to put any money into moon travel. But Elon Musk is working on it, so
I mean,
says we're going to
Discover
Mars.
takes
Well,
pictures
first it
of
was
the
that
Earth
we're
every
going
day.
to the moon. Now we've skipped it over. They said they're going to go back to the moon for the last 20 years.
for Artemis.
Someone actually owes me like $25K because they didn't go by 2025. They were so confident. This happens regularly, and then everyone forgets. It gets lost. It gets memory hold.
Who owes you that money?
I'm gonna give him a break. He came in. He came and asked me to. He like kind of groveled a bit. I'm like, "You're good, brother. It's all good." So.
Well, because they want to they want to build a space station on the moon so that they can deposit materials, create rockets, and then use the moon as a launching point for Mars. I don't know if Elon's actually planning on doing that, but he's saying.
Well, he
he's gonna
tweeted something how they even need a rocket that can refill in its path to the moon.
I mean, that's the mode of operations for Starship, right? Is the whole idea is you're launching a very large rocket, and when it gets into orbit, it's pretty much empty. It pretty much doesn't have much fuel, maybe just enough for landing, which is what they've been testing, but it doesn't have enough fuel to go all the way to the moon, right? So the idea is then you launch another one, and it brings up a little extra fuel. You do this over and over again and fill it up in orbit, and now you have a vehicle that can go to
But we were able to do it in 1969.
Yeah, why? If that's the case, how come they had enough fuel in 1969?
Because in 1969 they weren't reusing the rocket. That was a one-time use only kind of deal. This is reuse the whole thing.
Oh, right. It has enough.
It has enough fuel. It's got enough capability to come back. So Starship, it's stainless steel. That's heavy stuff. That's not great when you're trying to build a rocket.
You're saying when it comes back from the moon, it needs to be able to land itself.
Land itself.
needs a
Or
lot
get
more
caught
fuel.
by the tower, right? Like they've been doing.
That was crazy.
Mm-hmm.
Elon Musk caught a 30-story building.
Yeah, but that was more of like a magic trick. I mean, I don't know.
I think we got questions about politicians, but ain't nobody questioned the integrity of that Eratosthenes. I don't.
That is true.
What was that
Sticks
all
and
about?
shadows.
Yeah.
Well, that works with the localized.
I heard he was cheating on his wife. Who knows what's going on?
Primary documentation doesn't even exist of that ever happening either. Which
Well, the thing is that you can move the light source to the other side, and once you move the light source, you show that the Earth is fixed, and the light source can change its position. So Eratosthenes really didn't prove anything by what he did.
You can do it over. I could actually do that experiment on this table and then show you the math of what size sphere this table is. Because you have different angles, you assume spherical trigonometry.
Can I ask you a question about the stars, constellations?
Yeah.
Okay, so in the globe Earth, you have the northern constellations headed by Polaris on the top, the North Star, which is the tail of the Big Dipper, okay? And you got some other constellations, the Bear and Cassiopeia and all that around. And then on the southern, you have, near the South Pole, you have Octans, Mesmos, there's several other constellations
Southern
there.
Cross.
Okay? Yep. So if the Earth is flat now, how are you going to incorporate those southern stars that in the globe model take up a whole hemisphere? Okay? How are you going to put them into the flat Earth model that only has a dome, does not have a sphere, it only has a hemisphere? How are you going to fit those stars in there?
Yeah,
From the south.
Well, I mean, they could actually be embedded into the firmament itself. But what I actually think is...
Wait, what?
Yeah.
What'd you say?
They could actually be inside of layers within the firmament itself.
Well, we don't see them.
What do you mean? Oh, you mean from the
I
north?
have to travel.
So you're asking why I can't see them.
Here to the bottom to
Yeah.
see those stars.
Yeah, I mean, this is a
So
pretty...
how could they be embedded in the northern hemisphere?
No, well, I just meant the firmament itself, but I misunderstood your question. It's a pretty simple answer, right? It's like the same reason that street lights look like they're going down. So in the globe paradigm...
What do you mean?
So if I look at a long street, the street lights are all 10 feet tall, but they're going to
Okay.
look like they're going down.
So you're going to give me the perspective argument.
Well, that's
Is that
what
correct?
that's what it is.
How? How does
Because
that
the way we
explain?
actually made these measurements is we actually looked at Polaris and we took an elevation angle to Polaris and we had a horizontal baseline that goes all the way to the zenith underneath Polaris. Now on a globe, obviously, you can't extend a horizontal baseline hundreds of miles. And then what we did was went back a little further. The angle changes. Again, flat Earth measurement. The Earth measures flat. To even make the globe model, you had to make flat Earth measurements to get the latitude system. So basically, the perspective causes the star to drop down, just like the street lights, and you keep on making those angle measurements. What they then did was take those angle measurements that change based on your distance, and they put it into a spherical coordinate system. So...
Oh, wait a minute. If the stars come out at night all the stars come out at night at once. Okay, they're not spread out over time.
Yeah.
And we only see the northern constellations.
Yeah.
We don't see the southern constellations.
Until you go further south, right? I mean, you don't even have to go all the way to the
No,
east.
if I went on a flat Earth to the edge, I still wouldn't see them.
What?
You can go to any point on the Earth in that circular disk, and you still won't see the southern celestial stars.
Well, the stars are spinning, and as they come over top of you in your south, which they're actually more stretched out than in the north, and you can actually see them from a greater distance away than in the north, which is a major problem. I mean, you can see more constellations from a greater distance in the north and the south, which should be symmetrical.
There should be some place on your disk where I can see octans.
Yeah, it's just the stars are above us.
Where am I going to see it?
Out south is just away.
Out south.
It's away from north.
Okay, well.
What's the difference?
Tim, because we're running out of time, I want to get your guys' perspective or your reasoning. June 8th, the day that the Earth is 99% lit by the sun. How is that possible?
Because you are interpreting that wrong. We went over this.
No, I'm not interpreting it wrong. Austin, please tell Tim.
Well, that's
that he's wrong.
population. He's talking.
Yeah, see?
Yeah, but it is
Yes.
like it is roughly 65% of the physical sphere in actual
65%.
light.
You can only light, if it's a ball, you can only light 50%.
That's
of it.
because they're counting astronomical twilight as
No,
counting as sunlight.
it's
They
not.
are.
It's,
Right,
That's
yes.
not the only thing, though. That's not the only thing that makes it go over 50%. So, what's your argument for why it goes over 50%? It's not only astronomical twilight.
Well,
That's patently
astronomical
wrong.
twilight is the first
Basically
twilight
dark.
that happens.
Yeah.
It's basically dark. You need a telescope just to
Okay.
see it.
It's
and that
it's
is
the same
that
reason
is the
you see
furthest
the moon
extent.
with a glow on it.
Yeah.
Okay, it's filled the whole moon, and then you see a glow around the moon.
Yeah, that sounds like a local light source. But what I want to know is, like, you're going to claim the lights. You have to claim that the light's bending around. Partially bending around.
The first issue is you making the presumption that the claim at first is correct and absolute.
Yeah.
And so that's why I said Alex isn't immediately wrong.
Yeah,
He
yeah.
said that the globe is. Oh, no, hold on.
50% of the ball is lit.
And then he had to correct you. So the
90%
because of the
number comes with
population, because
the
the
issue is
population
you're
is
making
more
an
people.
argument against someone's argument instead of an argument for what is.
Well, yeah, what is known is that something like 90% of the world's population is in dilate, and they kind of stretch it based on astronomical twilight. But if you actually look at the projection of the Earth, if we look at the globe model, right, for those people at where they're located to also be in light and not just astronomical twilight, then the light has to actually cover more than half the ball. So you're going to have to claim the light bends around it, which, don't worry, people have no problem claiming it. They claim whatever they need to. They'll claim that the light will bend all the way around a ball if they need to. Whenever I see mountains from hundreds of miles away, the light just bends around the globe. But that is what he's talking about. There's two different portions, right? The,
Well, do
the
you
number,
disagree
the
that-
90% number is technically wrong if you present it as if it's physically impossible.
Speaking of that, I wanted to answer your question about Michigan.
Mm-hmm.
Okay. So Joshua in the wiki, you familiar with him?
Yeah, of course.
He's the guy that takes the pictures.
Yeah.
All right. So I have a big section about that in the book here. He only does it in April and May.
Okay.
Okay. Why is that?
Well, I guess the weather's better. There's
Well, the weather's changing. Okay. So the water keeps the temperature for a longer period of time than the air does.
okay.
Okay. So we're just coming out of winter. Mm-hmm. The water's cold. The air starts warming up.
Yes.
As soon as that air starts warming up, you're going to get light refraction.
Yeah. So you say it's just all refraction.
Well, that's
you
the
think it's
scientific
a
explanation.
mirage though?
Do I think it's a mirage?
I mean, basically, wouldn't that be? We're not actually looking at it. We're
Mirage,
looking at
illusion,
it.
whatever. The reason you're seeing Chicago skyline is because the light beam is being curved by the refraction due to the temperature difference between the water and the air.
Do you know about the Flying Dutchman?
No Dutch Bros coffee. I don't know the fun.
Are you familiar with the Flying Dutchman?
Tobacco.
Is that a boat?
The ship that was
Yeah.
So they would see ships flying above the water.
Yeah.
In the during the colonial period, and the legend emerged of the Flying Dutchman ghost ship.
Yeah.
It's just refraction of light made it appear that it was higher than it really was.
And sometimes
And
they
really-
were upside down.
Yeah, but really what happens in those is actually the boat doesn't just get lifted because the water would have to get lifted too, right? Because there's light coming off the water. It's actually that there's like a reflective inferior situation that happens for Fata Morgana. It actually it reflects down, so it creates a mirror effect, so it makes it look like it's up in the sky, but it's actually not. I don't dispute optical effects. What I do dispute is just assuming that the sphere is a certain size, therefore it must bend this certain amount, because I went to that Chicago location, and there were wildfires in the west, coincidentally, so I couldn't see anything. Like, you couldn't even see like a mile. But I talked to all the locals. They said you see it throughout the year. They said it's very frequent, certainly at sunset, that you see Chicago. So it isn't just those couple months or anything. It happens regularly. And then there is an observation that you can predict years in advance every year, 2 days a year. I think it's in September and February. In Canigou, right, in France, you can see the Canigou Mountains from a distance that should be impossible just using geometry on a globe. And based on that time of year, the sun sets behind the mountains and creates a silhouette. And you can guarantee see those mountains line of sight directly in front of you on that specific day. You can book your flight right now, unless it's like crazy.
Yeah, but you know what?
He has to assume that there's no refraction for that.
The Flying Dutchman crew upgraded their ship to a cargo freighter.
If your theory was correct, you should be able to get something as powerful as the Hubble Space Telescope, point it toward California, and you should be able to see some structure in California.
No.
Why not?
I'll explain it. So like we'll actually use the Canigou explanation because it works perfectly. So before the sun goes behind Canigou, you can't see the mountains. You can't see them. You could only see the mountains once the sun gets behind it. Now, a lot of people would take that picture and say, see, this proves the globe. The mountains below the curve of the earth. But then the sun gets behind it, you can see the mountains. The reason you can't see the mountains at first is because of attenuation, right? Like the light gets absorbed by the medium and it can't make it to you. Once the sun gets behind it, now the intensity of light is so much greater, it can actually make it through the medium, right? So the rate of attenuation is not going to affect the image as much, and you're able to see it. Now, even in the globe paradigm, you would have to admit that. You would have to now say at just 150 miles, I can't see mountains that are in front of me because light gets attenuated and absorbed into the medium. So this idea that you can see,
I have no problem with that.
So you couldn't see across the world. The telescope doesn't actually fight attenuation, right? Like we can see stars because we're looking up through the thinnest part of the atmosphere. And even there, we actually have 1 to 2 degrees. We have almost a whole degree that we can't really know.
Well, what's the farthest you think the Hubble telescope can see through atmosphere of the Earth?
You mean like laterally, like horizontally? Yeah. Oh man, I don't know. It would few hundred miles, because we see a few hundred miles regularly. And Mount Wilson, if you got a higher elevation,
how could you prove a flat Earth then if you can only see a couple hundred miles?
A few hundred. I mean, we have observations in planes with infrared where we've seen 5, 6.
Within that range of 200 miles, would Hubble be able to see a sublimation of the Chicago skyline?
It's all based on the attenuation of the atmosphere. It's always going to be based on the atmosphere. The light gets absorbed. The Canigou proves.
Okay, so your answer is how light's affected, right?
Yeah,
that's what my answer to
but
was.
You're claiming it's bending at a certain rate. I'm just saying that light's attenuated.
Okay, so I'll say it's attenuated and it's bending.
But I can actually.
How does that prove a flat Earth?
Well, it doesn't. I can prove. Well, yeah, but you have to prove it, right? Like you can prove the rate at which it attenuates based on the actual medium. Based on the turbulence, the turbidity, and the actual
Okay, so you have third-party factors affecting how the light comes into your I-beam.
How far it can get to you from.
Okay, so how does that prove flat Earth?
Oh, because we can make observations consistently, predict them in the future from hundreds of miles away, where the mountain should be miles at times, up to 2 miles below Earth curvature. I can book a flight.
How could you prove that if light's attenuated and it bends?
Well, the light attenuation is just proven by the fact you can't see the mountains till the sun sets behind it.
That means it's the light's being affected somehow, right?
It's being absorbed by the medium. Once the sun gets behind, the sun's so much brighter that it makes it through the medium. But you're claiming that it's bending, and that I can book my flight right now.
You don't believe
go
in
see
light
that
reflection?
mountain? Yeah,
refraction.
I do believe in refraction.
You believe temperature can cause light refraction?
In a singular medium, it can have effects. You can label that as refraction, but Snell's law is based on 2 medium, and this word's just thrown around. It's just thrown around. No one can show this in a lab. I keep asking, show me an equation, because according to you...
Wait a minute. My question was, do you believe light refraction can be caused by temperature difference between water and air?
Yeah.
Okay, so you can't discount light refraction like we're just making this up.
No,
right?
No, not when properly defined what refraction means. But to every time to say, I know this amount of refraction's happening without looking at the variables and without actually making the measurements of the temperature gradients, the density gradients, and just saying it must be curving this amount because my presupposed sphere...
We don't say that, as a matter of fact. Mm-hmm. As a matter of fact, if you look at the Chicago skyline photos, they're all different. Some show buildings coming higher up out of the water. Some show buildings that are thinner than they really are. Some show more color. Others are gray. Every time you take a picture of the Chicago skyline, it's different. Why? because you get different attenuation, you get different refraction, all kinds of things are different every single day.
Sure, but when it's clearer outside, we see further. And your paradigm...
Okay, that's fine.
Yeah, but you have to claim when it's clearer outside, that's when there's the most refraction, because when it's clear outside, we're seeing the furthest.
Clear has nothing to do with how much the light's refract.
Well, if it's the conditions of the medium that are supposedly refracting it, then
the temperature is the cause. Okay.
Okay, and
because it makes the air thinner or thicker.
One more thing before we wrap up here. The horizon in a globe is like this physical edge of a sphere, right? It's blocking things. It's a physical location. It's geometric. As in, on a globe, there's a physical location called the horizon blocking things in the distance.
That's an apparent horizon.
Wait, is it physical or apparent?
No, you see an apparent horizon because refraction's always there. You're not living in a vacuum.
So you have no evidence of this physical one. You have to assume it's there. We see the horizon goes up and down, moves all over. We can see from 100 miles away consistently. I can shoot lasers over frozen lakes, different colors, different heights, even if they're different distances, they'll stay the same height over frozen lakes. I can see specular reflections over great distances. If the surface was convex or concave, you wouldn't see that. And there are all the evidence shows, and just saying the word refraction isn't a get out of jail card of all the physical evidence that consistently shows we can see way beyond the curve. You have to prove there's a physical hill in front of me blocking things, and there's simply not. I can shoot radar through it.
So I've witnessed a Falcon 9 landing on the drone ship. You know how they land on the boat in the water? Mm-hmm. Just after they were doing a Dragon test and they accidentally blew up one of their Dragon capsules, they couldn't land at the landing zone because they had debris all over it. So they brought the drone ship in real close to shore, 17.8 miles offshore. So I was able to witness this Falcon 9 landing on the drone ship. The engines are very bright, as this thing's landing, and I'm watching it obscured by the horizon as it's landing 17.8 miles offshore. The bottom 2/3 of the rocket were blocked. According to the globe, that's what I should have seen with refraction accounted for. So yes, refraction's a part of it. Also, it had a nice specular highlight across the Atlantic Ocean coming up to me that was very visible. So if it's not curved, why can I see a specular highlight? And then if it's not curved, why is the bottom 2/3 of the rocket blocked after it lands?
You can see specular reflection. It's because that requires a flat surface. And
if it's flat, then why is it blocked by the lower 2/3 of the rocket?
So you made a false claim about the specular reflection that only works on a flat surface because you get a diffuse reflection if it's convex concave. But the horizon's apparent. It rises optically, and the most dense part of the atmosphere is the bottom. The most dense. So that's going to block the most things from the bottom. Now, you said you accounted for refraction. You did not measure the density and temperature and then put it in a refractive equation and determine how much should be missing. What you did was notice that it didn't match the globe. And then you had to add refraction because you saw too much of the rocket. It should have been more blocked. You assumed, it must be lifted up behind the curve, and it's actually an illusion.
No, I recorded what the temperature was that day. Anyway, so the bottom 2/3 of the rocket was blocked, and the bottom part of the rocket's where all the flame is. That's the hottest, brightest part of it. So why am I able to see this dim little part at the top, but not the bright part of the flame at the bottom? And I'm getting specular highlights, reflections off the water that's supposedly flat, yet it's blocking the 2/3 bottom part of the rocket. Last thing I want to ask you, Whitsitt, before we wrap up.
Are you claiming bottoming up obstructions impossible on a flat Earth?
So you haven't explained it. That's for sure.
You're entirely new to this.
But here's the thing I want to ask you, Whitsitt, before we wrap up, is you're going to Antarctica for TFE, right? And I applaud you for taking up that offer. So what are you expecting to see? I want to know what you're expecting to see. Are you expecting to see the sun set in Antarctica, or are you not? And if so, why?
I have no idea. I don't actually have an expectation. I don't know. That's why I'm going.
What if the Earth is flat, but like that? You know what I mean? Like, does that work for you?
No, I think it would be a bowl, if anything, like a basin. The ocean, right, is got upturned.
Then wouldn't you see the sun all the time?
Well, it just gets so far away you can't see it. As to what's going to happen in Antarctica, I don't know. Like, that's why I want to go, is because
if it gets far away, it would get smaller, not just go down.
Well, technically, it actually does get smaller. Even in the globe paradigm, it gets smaller. It actually changes to noon. It should change again. That's never been measured. But
how do you explain the sunset?
It's just like the streetlights, right? So like as it moves away, it looks like it goes down, and then it gets so far beyond you can't see it through the air anymore, right? It goes beyond that point. The horizon's apparent. It gets behind the convergence point. Just like railroads converge, if you flipped them on their side, that would be like the sky and the ground. That's what perspective does. And even in the globe paradigm, they claim like when you see the sunset, it's actually not there.
But you're arguing that like the sunset is vanishing point?
Well, yeah, it gets beyond the you could say quote unquote vanishing point. Sure, it gets beyond the limit of your vision, the apparent horizon. It gets beyond the convergence point.
Is that because it's only 27 miles in diameter?
I don't make any claims as to the size, but I will say you can prove this. Sometimes the sun disappears above the horizon, and even when it disappears above the horizon at sunset, it has a perfect horizontal line cutting off the bottom of it. So how's that work? If it's the curve of the Earth, right? But it's not. It's because there are horizontal layers of atmos. The sun moves beyond it, and so all the evidence shows the Earth.
Will you
is-
be willing to admit that the Earth is round if you go to Antarctica, and it looks round?
Well, I don't see it looks round. I mean, I'm going to take an infrared camera, and I'm going to probably see 100, 200 miles in the plane. So Antarctica, the only way it would prove it is if I could fly over the South Pole, pop back up on the other side. I'm very interested in the observation. That's obviously why I'm going. It's 11 days. It's very inconvenient. I don't blame Alex for not going. So it's 11 days. It's super cold.
Alex is scared.
I am scared.
It's also kind of scary in a way, right? So, but we'll see what happens.
We're gonna wrap things up. This was a lot of fun. I love this. It was great to have these varying perspectives, all going at it. And so smash the like button, share the show with everyone you know. We got more coming up later today. YouTube.com/TimCastIRL tonight at 8 p.m. But we'll go around with final thoughts and shout outs. Alex, do you want to say anything before we wrap up?
Well, I just want to thank all you guys for participating in this. It's very nice for you guys to make time to come here. And there's just a lot of questions that are still unanswered, in my opinion. And just look into it. Don't believe anything I say or Austin or Bob or Scott. Just look into it yourself and then make whatever assumption you can from the evidence that you see.
Final thoughts?
I'd say don't believe him, believe me.
There you go.
Just kidding.
Don't believe me. I'm not a role model. I'm not. You don't want to be like me. I'm insane. I wear tuck-friendly bathing suits at city council meetings. My point is, do your research and look into it yourself.
Yeah. So I would just say this is hard stuff. It's hard. Science is hard. It's never easy. We have a lot of data. We have microscopes, telescopes, oscilloscopes that bring in all kinds of data. Connecting the dots and interpreting that data correctly, that's the hard part. And that's where we are right now.
Is there somewhere people can find you?
Yeah. So www.robertsongenis.org. And we have a science website also, journeytothecenteroftheuniverse.com.
All right. Sir, final thoughts? Anything to shout out?
Yeah, so I think the conversation is way more in depth than people realize, and I would just say look into it. There's a philosophical bias to this idea that the Earth is special, and in the center it has philosophical implications, and just don't shy away from looking into it because people will mock and ridicule you. The evidence is overwhelming that the Earth is stationary, thus in the center, and I would say it's overwhelming that it's actually a topographical plane. Just look into it, to each their own, and science is not about dogma, right? That's the death of knowledge. So you should be able to have intellectual discussion, disagreements without freaking out. And yeah, you can find me Whitsitt Gets It on all platforms or whitsitt.tv.
All right. So I want to thank Whitsitt for inviting me to this debate. I had a good time. Thanks, Tim, for hosting this. You can find me on YouTube, Astronomy Live. I do a lot of work developing rocket tracking software, satellite tracking software. I actually have to account for stellar aberration and doing that stuff too, which is kind of fun. So it's been great for me to sort of engage with ideas that I don't necessarily hold, but to be able to go out there and collect evidence yourself. And that's one of the things that I love about astronomy so much, is that it's so accessible and anyone can get involved and do it. You don't need a big, expansive telescope to get started. And you can go out and investigate these things yourself and take your own measurements because, I now am happy and proud to be able to say that I've measured the size of the Earth myself. I've measured the distance of the sun myself. And these are all things that anyone can do. If I can do it, anyone can do it. I'm not a professional astronomer. I'm just an amateur astronomer. I'm just a neuroscientist who loves playing astronomer at night. So thank you all.
Right on. Well, everybody, thanks so much for hanging out. Like I said, we'll be back at 8 p.m., youtube.com/TimCastIRL, and we will see you all then.